Good afternoon, everybody. This is a live update as we have a tornado warning that has been issued near the Fairdale area. This is in northeastern North Dakota as we have explosive development of supercell storms from the southeastern portion of Manitoba all the way down into central North Dakota, southwest of Devil's Lake. These are developing along an outflow boundary from southwest to northeast. The forecast models are showing this explosive supercell initiation, and that's the first one that got going off to the north. Look at that thing lifting northwest, and it actually split as well. See it split? There's the left split emerging up toward the Milton area. This is definitely starting to transition toward more of a windbag. You can see the outflow coming in from this other left split. Right now, photographs equally favor left and right movers, and you can definitely see this outflow boundary that tails all the way up to these storms. Right now, this outflow boundary is more north-northwest to south-southeast. It's right in the western portion of Minnesota, streaming up toward the developing storms. Definitely an environment that's characterized by relatively low-level shear, interacting storms, potentially large hail-producing storms. This one to the southwest of Devil's Lake looks to be the most dangerous storm right now. Another one that's developing back to the west of New Rockford near the Fessenden area. Off to the northeast, though, this formerly tornado-warned storm southwest of Milton near the Fairdale area. It looks like the couplet lifted just a little bit to the north and definitely is getting impacted by the outflow that's coming into the south. Let's take a look at velocity looped. And we can definitely see the circulation that prompted that warning lifting off to the north as a supercell storm, propagating north-northwest with the southerly winds. Must be relatively weak upper level flow so far, but I do think that eventually this tornado warning is going to be allowed to expire. I'm not seeing incredibly strong rotation with that storm. Of course, there certainly is the potential for land spout tornadoes that can get stretched into the vertical across this area. Off to the northeast, severe thunderstorm warning south of Winnipeg. This is in southeastern Manitoba. Large hail, mainly going to be the main threat with these. I don't think that the tornado potential is actually through the roof for these storms. These storms back near Devil's Lake are trying to rotate. Remember, we're looking at the radar site to the southwest out near Bismarck. So this is actually an anticyclonic couplet. This is the inflow to the east. This is the RFD, and it does look like there's an anticyclonic couplet on this. Minnewacan to the southwest of you. Probably about to split. That's a sign that this supercell is likely about to peel off a split on the northwest side. That's why you have an anticyclonic couplet. Green are winds toward the radar, red are away, and you can track this boundary all the way down. There's even a storm developing just to the north of Bismarck. And it looks like that one also might have already... Oh, no, those are just two separate storms. You got one on the cold side of the boundary. It does look like we have some easterly winds and a weak low pressure system located near the Bismarck area, but these storms are erupting southwest to northeast along this line, and this is starting to set the stage for windbag potential, it appears. Definitely a windbag potential. You can see some outflow further east, unzipping this entire line, starting to unzip. I'm not seeing incredibly tight rotation with this. This could be kind of a mesoscale accident type of a scenario here. Converging boundaries, potentially. That does look like that's a cyclonic couplet just to the northeast of the Fairdale area. Probably a mesoscale accident. You have this outflow that's surging in from the south. You still have the leftover hook of our old storm. Clear air coming in, likely a rear inflow jet here. A little bit of a rear flank downdraft streaming in. There's the mesocyclone. And I do think that that is a radar artifact, potentially. It could be a mesoscale accident just because we have a lot of converging boundaries in this area. That's just some clear air action. It's a radar artifact. I'm not seeing a debris signature along that immediate area, but it does appear like it's a pretty strong couplet. And the fact that it just appeared like that too, you don't really have much in the way of big storm relative inflow to the east of that. It does have relatively strong gate-to-gate wind shear just northeast of Fairdale, but to me that looks like more of a radar artifact, converging boundaries, potentially a mesoscale accident. And now we have this whole severe thunderstorm warning that has been issued with a tornado possible tag, hail up to 1.75 inches in diameter all the way up to the Manitoba border. Saw a tornado up here like in 2018 near the Winkler area. Pretty incredible tornado. I think that was 2018, maybe 2019, when we were in southeastern Manitoba when I hit that porcupine, unfortunately. A porcupine that was about the size of a bear that ripped out my wheel well big problems. So I do want to look at the shear profile out of Bismarck right now as these storms are starting to initiate. Let's see if we can use radar to try to infer the wind direction, and then we're going to look at surface map, see what the wind direction. This is the front that's going to continue to excite storms all the way up here to the northeast, and then you have the outflow boundary that is oriented north-northwest to south-southeast additionally. So let's take a look at some of the environments that these storms are embedded within. We'll start off with the RAP analysis. We do have a severe thunderstorm watch for this area with low tornado probabilities. Oh, I thought I just heard thunder outside here. It's about to flip out. Here is the latest RAP analysis showing you that diffuse 1005, 1006 surface low centered over central South Dakota into far southern South Dakota. And you can definitely see the easterlies along the northern edge of the surface low, southeasterly winds there as well. Basically easterlies on the northeastern quadrant of the surface low, and you're really going to need southeasterly winds. You're probably going to need outflow boundaries. This dominant storm here, something's going to have to come out of this cluster in northeastern South Dakota, turn right, and then move southeast right along that outflow boundary. Some of the earlier forecast models, the convective allowing models, like the HRRR, were showing that. And a big-time Cape blob. A lot of times you don't get convective initiation right in the middle of these Cape blobs, and you get them along the periphery, the northwestern periphery of the Cape Max, right near the gradient. That's usually where you want to play with targets like this, because that's where the storms initiate. There's also the potential for horizontal spin, vorticity along that boundary that can get stretched into the vertical and can potentially produce tornadoes. Plenty of instability, but your low-level shear really lacking. You're talking about less than 50, 0 to 1 kilometer storm relative helicity, and you could probably look at some surface vorticity along that boundary that can be stretched into the vertical that can potentially happen. And there it is. Bam! You got low-level Cape. You also have surface vorticity that's maximized along that boundary. And so clearly that is the zone. I would say that there's land spout potential along this, but it's probably not dusty enough to even see any of those land spouts. Yeah, the red definitely maximize the low-level Cape across this area, and the surface vorticity along that boundary is also maximized. So the co-location of those two parameters there could lead to some land spout potential. Overall, the greatest 0 to 3 kilometer EHIs are a little bit further west, where you get more northeasterly surface winds and a little bit actually due northerly surface winds back there behind the front. So this is definitely the cold front. Winds to the northwest shift to a northerly direction. Winds off to the southeast are out of the southeast, and this is definitely going to compress as it goes off to the south, reinforced by outflow as well. A little weak surface low, some storms that are trying to develop in the vicinity of the surface low as well. See how the wind shear evolves with time. Look at that right mover though that tries to ride the outflow boundary southwest in eastern North Dakota. Watch this storm right there, and watch as I go forward with time. That's where there's going to be tornado potential, is with that storm that's able to anchor along the outflow boundary as it slides off to the southeast, eventually moving into western Minnesota. But that storm is going to be capable of moving along an outflow boundary and stretching that vorticity into the vertical. Eventually it's going to pass into northwestern Minnesota. And still you just don't get any wind shear. The low-level wind shear is really meager. It starts to get a little bit closer to 100 meters squared per second squared, 0 to 1 kilometer helicity as you get up into northwestern Minnesota. But that's at 25Z. That's 8 o'clock p.m. Central Daylight Time. Normally you'd expect that low-level jet to really ramp up. But the low-level jet is concentrated from eastern Nebraska off to the south. You can see some of those greater low-level wind shear values down into Alaska. I'm just not seeing... You'd normally, if you saw a big blob of like 200 to 300 0 to 1 kilometer storm relative helicity ahead of this, that's ramping up just after 8 o'clock, then I would think that this could become a prolific tornado producer. But it is going to be dependent on a mesoscale accident. That storm's going to have to latch onto an outflow boundary. I've never really believed 100% in the process of a storm latching on an outflow boundary and mechanically stretching it into the vertical. I think that that process usually gives you more land spout tornadoes. Interestingly though, the storms don't really charge into southeastern North Dakota, where you actually get some decent low-level wind shear. Northeastern South Dakota, southeastern North Dakota. If these storms were moving a little bit faster, they'd have a chance to move into that good air and potentially produce some tornadoes. That's why the severe thunderstorm watch is in place instead of a tornado watch. But still, tornadoes are possible. There is a low chance of some tornadoes. So I'm going to be looking at the shear profiles. Let's just look at Grand Forks, since it's a lot more representative and it's in the vicinity of the outflow boundary. I think we're going to see a real small hodograph that's just compacted. Come on. There it is. Well, your surface wind is south-southeast at about 15 knots. The hodograph is very marginally supportive of a low-end tornado threat, but you're going to need an outflow boundary. You're going to need extreme instability. Your surface wind southeast to northwest at about 15 knots, or 1 kilometer wind out in the same direction at about 25 knots. That only creates like 5 to 10 knots of 0 to 1 kilometer shear. Very short shear vector. To realize tornado potential, you need a 0 to 1 kilometer shear vector that's at least 20 to 30 knots. That'd be like a southeasterly surface wind at 10 knots, a south-southwesterly low-level jet at about 40 knots. Then you're talking close to a 30-knot shear vector. You do have enough bulk shear, though, to cause storm relative outflow with a right-moving storm motion southwest and northeast at 10 knots. So in order for that storm to dive southeast, propagation is going to have to dominate over translation to get a storm motion like that, like is being shown by the HRRR. That's going to have to be a storm that wants to propagate into the moisture. It's going to continue to redevelop its updraft on the south side of the circulation as it moves off to the southwest. This is basically a straight line hodograph, northwest to southeast, and that's why we have equal favoritism of the left movers and the right movers right now. You have a lot of storms that are congealing together. Going back to radar, not surprisingly, our tornado warning has been dropped, replaced by this large severe thunderstorm warning. Walhalla down through Langdon, Cavalier, that's anticipating outflow to potentially drive these thunderstorms off to the northwest. Boy, that severe thunderstorm warning extends way to the northwest of those storms. I think eventually these are going to develop a collective cold pool, and it's possible that a dominant right-moving supercell will be able to latch onto this outflow boundary that's over the Red River Valley. There you can see that streamer of an outflow boundary just pumping into those storms. And if a supercell is able to dominate out of this cluster, it'll have a chance of turning southeast and moving right along that outflow boundary that right now is going right through Grand Forks. So there's the outflow boundary. You can have a little bit of spin associated with this. We have temperatures that are a little bit more cool on that side, a little hotter on this side. That creates horizontal spin around that boundary. You just basically envision like a snake that's spinning horizontally, just a spinning tube streaming up into those storms. And then you take a vacuum cleaner and move it up over top that outflow boundary. It is going to be capable of flipping that spin into the vertical, and that's how you can get the development of a couple of severe storms. This storm to the southwest of Devil's Lake, congealing. That's kind of the story of the day. Everything is congealing together out here. Mass chaos. Explosive development of supercell storms, but more importantly, just updrafts all over the place. Marginal wind shear for tornado potential. Extending into northwestern Minnesota, kind of some elevated supercells up here on the cool side of the boundary. A lot of times you get, this time of year, you get these outflow boundary setups where you have the outflow boundary oriented northwest to southeast through the Red River Valley, for example. Just a lot of times you'll get that happening. You can look at echo tops as well to kind of assess the relative intensity of a storm. This one's southwest of Devil's Lake, taking full advantage of that 5,000 to 6,000 Kate blob. that it's embedded within. Very high tropopause though this time of year, which is the upper part of the upper atmosphere, or the lower atmosphere, excuse me. So very high echo tops. Large cape is definitely a possibility. But just because you have large cape doesn't mean that you're going to have large hail. You really need those supercells with strong directional shear that are moving into an environment, usually with northeasterly winds, a lot of times even slightly elevated. That can happen out there. Severe thunderstorm warnings as well over southeastern Manitoba, southeast of Morris, east of the 75. These aren't that intense right now. There's Highway 59, Steinbach area just to the northeast. This is tough chase terrain out here, the southeastern corner of Manitoba into the southwestern corner of Ontario. Test. So definitely do have storms that are developing southwest and northeast. It's very possible this one could mature and be a supercell that dives off to the southeast and is able to anchor on the outflow boundary. I could turn this up. I got my microphone here. Yeah, we had the tornado warning earlier. We just lost that circulation. Mike, it is so expensive for me to fly to Omaha for the World Series. I don't know if it's going to be happening this weekend. Probably cost me like $3,000 to get out there and watch Oklahoma win. I am a little bit concerned about this circulation southwest of Oberon. Even though this storm is congealing with the storms immediately off to its southwest, you can at least see that there is some decent storm relative inflow here. Looks like my crawl text is upset, doesn't it? But that's the storm that we're watching, west of Cheyenne, spelled a little different. Cheyenne out there. This is North Dakota, Devil's Lake, just off to the northeast. This is Devil's Lake. We're looking off to the southwest at this spin, southwest of the Oberon area. Doing a little bit of a live radar breakdown. Still waiting on the Dominator 4 to get fixed, but we're also watching the tropical wave that is off to the east of the Lesser Antilles right now. And there certainly is potential that that tropical wave could even become a tropical cyclone on approach to the Lesser Antilles the second half of this weekend. That's a possibility. There are some models, long-term models, that bring that thing into the Gulf of Mexico. I'm not sure if that's going to happen or not. Does have some potential to happen. Thank you very much, moderators, for tuning in. Thank you, Gina K. She is the OG moderator on this platform. Thank you, Evil Gamer. Thank you, Calm as Chamomile, another OG moderator. Got me through the early season. But these storms are congealing together. This is cloud seeding. So you get a storm that develops right here, and then it rains into the updraft of the storm just immediately upstream. That is the cloud seeding via natural processes here. And this thing is just spraying that supercell like a fire hose right now. Live radar breakdown. Thank you everybody for joining me here today. Breaking this down, northern plains. Normally I'd be storm chasing up there. I would have flown in if I thought that the tornado potential looked a little bit more robust, and I would have justified the expense to get up there. But instead, we're working on some pretty important things here as well at Team Dominator. Pretty excited about it. Had a real exciting call a little bit earlier today. Just think ultimate storm chasing machine. That's the key. So this is just southwest of Oberon. This is the circulation that we're watching. Live emergency radar breakdown of severe weather outbreak in the northern plains. Major windbag potential. Tonight, major windbag potential tonight through northern Minnesota. Boom. New tornado warning has been issued, and it's that same storm radar indicated again. A little bit east of Fairdale. Man, they are warning everything out here. You do have this little area of increased storm relative inflow happening. This zone right here is the storm relative inflow. You do have a broad couplet. That includes Adams, North Dakota, get in your safe place. Definitely could see an embedded supercell structure within this. It's a HP supercell structure, but you can certainly see cyclonic curvature to the overall precipitation pattern. Maybe a little hook-like appendage sticking out there to the northwest of Langton. You got a couple new bubblers, some renegades that are trying to develop off to the east near Grafton. Always happens like this. You get a north-south oriented outflow boundary to the east of these. That's happening through Grand Forks. Right now, it looks like the models are showing this storm to potentially dominate, peel off that southwest and northeast boundary, and then move along the outflow boundary that's centered over the Red River Valley. But it does have a bit of a circulation. It's broad. I'm not seeing a tornado. It just tightened up on the latest scan, however, just to the east side of Adams, North Dakota. We have a very marginal low-level wind shear, so these storms are really dependent on mesoscale accidents out here. Interaction of outflow boundaries, storm interactions that need to happen. Not surprising, I'm not seeing evidence that there should be a debris signature on a storm like this. But there's your little hook echo. A tornado circulation, a little mesocyclone is embedded within this storm. And we can also look at the echo tops. Pretty high echo tops on this. That's a good way to pick out the dominant storms out of a convective line like this. Probably have a mesocyclone with this and a mesocyclone here. A rotating updraft has a stronger updraft, and that causes it to penetrate higher up into the troposphere. So that is exactly what is happening right now. Live radar breakdown, a new tornado warning just on the east side of Adams. Thank you, everybody. Hit that like button, notification bell if you enjoy my weather reports. I really should be out of the field right now, waiting on my vehicle to get fixed. This is a really marginal setup, however, for tornadoes, but it is a big-time setup for destructive winds, large gorilla hail. For those types of things, this is a very favorable setup. I think this is definitely going to qualify as a severe weather outbreak. Maybe even a derecho if it is long-lived enough and that windbag is able to propagate all the way across. Live emergency update on a tornado warning. Northeast North Dakota. Just east of Adams. There's also in Adams, Nebraska. This is Adams, North Dakota. Nebraska late night tonight could get some severe weather. There's a very favorable parameter space near Omaha and areas late night tonight across eastern southeastern Nebraska, but the models just don't fire any storms. No upper support down there further south. We're watching the circulation on the southeast side of Adams here. That's very diffuse. Kind of surprised. That's a pretty diffuse mesocyclone, a very broad circulation. I'm not seeing too much in the way of evidence that that storm is going tornadic. There's the 3D option, which really just makes it seem like higher reflectivity extends higher up in the storm, but it's really just a way to view the storm in a 3D sense. You can see the higher reflectivity off to the south. You can certainly see the higher reflectivity near our tornado warned storm. And this is the storm off to the southwest that has even greater reflectivity, just a severe thunderstorm warning for that one. But it's not an echo top. that more just equates high reflectivity with a storm that's extending higher up. Still, though, it is a great way to view these storms in a relative sense and to see which ones have greater reflectivity. But this looks to me like it's congealing into a mess, an absolute mess of a windbag, but a destructive windbag at that, capable of producing some potentially very large hail. Storm to the southeast of Morris, Manitoba. Explosive development along an outflow boundary straight into Karlstad in the northwestern portion of Minnesota as well. But the photographs are not incredibly impressive for this. I do want to look at this storm to the north of Bismarck again. Conglomerate of early supercell storms. Some bean shapes there to the south of McCluskey, north of Reagan. Definitely a cluster of storms, but really only the southern periphery is getting unimpeded southeasterly winds into it. Take a look at the chat, everybody. Say hello. Thank you for joining us. Thank you, moderators, too, for tuning in. I'm not really based in any state. I really live on the road. Thank you, Evil Gamer. Yeah, please hit that like button. Never stop chasing. Right now, I'm actually in South Carolina. I'm in upstate South Carolina. That's where I'm getting my vehicle fixed. Troll Chaser, Evil Gamer, Gina K. Thank you, everybody, for tuning in. Free Bird, thank you. Thank you, moderators. Aaron HQ. Thank you, everybody. I don't think there's going to be a tornado today, but it's possible, so that's why I'm doing more of the radar breakdown right now. Smash that notification bell. But this severe storm back near Bismarck, definitely a conglomerate, more of a conglomerate of storms. This here to the southwest of Devil's Lake. This supercell did have some decent rotation north of Bremen. But right now you just have a large zone of some storm relative inflow, a broad convergent line northwest of Bremen, Hymondale area, up toward Devil's Lake. Severe thunderstorm warnings all the way up to Devil's Lake. Tornado warning still exists here. It's radar indicated, of course, and a very broad circulation at that. I'm not seeing anything incredibly tight. The circulation, though, is just to the east of Adams. Heed that warning. If the red box gets issued for you, then definitely it's very important to heed those warnings. And that circulation doesn't look bad. It's trying to broaden out a little bit. Eventually, this cell is going to start propagating off to the east-southeast. It can't exist in this state on the southeastern periphery of this convection forever. It does appear that there are a couple of mesocyclones that are coming out of this tornado warning. It does appear to be getting more organized, and notice how this circulation is lifting off to the northeast toward Edinburgh. Right now, the rotation is just to the east of Adams. But it is a circulation. You can see evidence of a rear flank downdraft wrapping in there. A little bit lower reflectivity wrapping in. That's the RFD that's trying to cut into this circulation. Got to look for those comma heads. And it is pulling in some inflow from the southeast. You can tell that it's not pulling in a ton of inflow because of how this looks on the southeastern gradient. You don't have a really tight reflectivity gradient on the eastern periphery of these storms. Definitely a lot more diffuse on the southeastern periphery. That's evidence that there's probably not huge inflow coming into these storms right now. And we can definitely confirm that based on the surface analysis. This storm just on the Manitoba side of the border, north of Dominion City. Chased a lot up there. You do have some inflow to the north of that into that storm. A little bit of inflow flowing into it. Severe thunderstorm warning. Seems like they're more concerned about flash flooding on the Canadian side, probably because of how high those rivers are. And we still do have that storm relative inflow on the storm embedded in that cluster to the southwest of Devil's Lake, but I still think that's probably going to be more of a severe storm. This circulation has gotten even more broad, more decoupled from the storm relative inflow just to the northeast of Adams. Just have to keep watching that as it lifts off to the northeast. Maybe a little bit. This is the stronger mesocyclone. A little bit of storm relative inflow on the eastern side. When toward the radar, the back side of this circulation, pretty broad mesocyclone there. Thank you, Facebook. Facebook's actually kind of my main original platform that I put so much work into over the years. Yeah, we're obviously watching that tornado warning. Heidi, we've been breaking it down already here for several minutes. And we do have the new tornado warning. You're right, they did warn it. Good call. And it's all due to that storm relative inflow increasing here and then trying to wrap back toward a broad circulation just southwest of Oberon. It does seem like they're warning a lot of these storms, even when the rotation is relatively broad. I definitely support that. You could easily stretch the vorticity along that front that's oriented southwest to northeast into the vertical. This is the embedded storm that is getting cloud seeded by this fire hose. Look at this fire hose, a new updraft here, big flanking line of towers, and just spraying this storm downstream with big time rain and hail. Cloud seeding is happening. Oberon, Cheyenne with an S. But that circulation is right about in this area. And again, notice how the gradient of reflectivity is so diffuse. You can really tell that tornado potential is going to be dependent on mesoscale accidents, storm interactions. But there's your circulation in between Cheyenne and Oberon. You have an increasing area of storm relative inflow on the east side of that circulation. You have northerly winds on the backside, and that is the circulation that we are watching right there. Big storm relative inflow into that storm. Echo tops are also likely quite high on this one. Pretty high echo tops, as you can see. Back building all the way down that flanking line. Just seeding the hell out of this storm. Towers feeding in over and over again, seeding that storm. But very high echo tops for the tornado warned storm. We have 2 tornado warnings right now. We have this tornado warning on the southeastern periphery of the convection. This is north of Adams, west of Edinburgh. Embedded circulation there. This candidate here has a chance that if propagation starts dominating, it'll turn off to the southeast. And if this thing is able to latch onto an outflow boundary and turn down the Red River Valley, then there is an outside chance of a tornado potential, even though the low-level wind shear out ahead of that storm is incredibly marginal. The rotation's starting to decrease on this storm. The Edinburgh one. Just changed radars, though, or further away. And notice how I'm scanning higher up in the storm. Even though this one's closer to Minot, you're not seeing that deep mesocyclone that's associated with this storm. Go back to the Mayville radar site. Then you can start to see that circulation, but it's very broad. A really broad circulation. Red, those are winds away from the radar site. Southeasterly winds. Green are winds toward. And you do have a broad circulation there. Quite broad, southwest of Edinburgh. This circulation's a lot tighter south of Oberon now. So there are some big northeasterly inflow streaming into this circulation. That is about where the tornado would be located if it is. Right now it's radar indicated. I'm not seeing anything in terms of debris getting lofted in the air right now using the dual pole products. And I don't think that has the look of something that has a tornado on the ground right now. But it is trying to go through the motions of producing a tornado. Looks like you got the northeasterlies feeding into the mesocyclone. You have the RFD wrapping around the backside. A little bit of a bulge out as well. And that's where the circulation would be located. We could loop it to get some motion. And it's just drifting off to the northeast at about 10 knots, that circulation. And it could easily turn northward. A lot of times these supercells like this will curl northward and the vortex will be shed. And it does look like that latest scan with storm relative inflow is even increasing into that circulation south of Oberon. And see that it even has that curvature to it, the inflow coming in from the east and then curling into that circulation. Pretty classic. Radar indicated, not surprising. Can definitely see kind of the cyclonic curvature with this storm too. Just southwest of Oberon, northwest of Cheyenne. Cheyenne there with an SH. An embedded supercell storm. And you can tell that these are embedded supercell storms by looking at the echo tops. Look at how high these echo tops are. We're starting to get into the pink. getting close to 60,000 feet with these tops. So that's what happens when you have a rotating updraft. The storms will bubble up into the tropopause, even extending into the stratosphere. That's called an overshooting top. This one is probably rotating as well, west of Brockett. This one, the tops are coming down. The tornado warned storm northeast of Adams. Still radar indicated, however. $0.5 size hail. Storm capable of producing a tornado over Adams. Well to the west of, northwest of Grafton. And you can start to see that cyclonically curved precipitation that's wrapping around. You can see this comma head with this embedded supercell storm. Definitely takes a trained eye to kind of dig this supercell out of that environment. But just northeast of Adams, you could definitely see where that mesocyclone is going, in between Adams and Edinburgh. Broad, very broad. Maybe get a couple gustnados along the southern periphery. But that's the circulation just northeast of Adams, southwest of Edinburgh. That's where we're watching for this thing to really tighten up, right along that shear zone. But you can see the difference between this supercell and the one southwest of Devil's Lake. You don't have all those bright colors. You don't have a ton of storm relative inflow out ahead of this one. Looks like you got a little anticyclonic couplet back here near Adams. Probably gonna get a lot of that turbulent action out here. This one is much tighter south of Oberon. Still a radar indicated circulation. Let's take a look and see if there's a correlation drop. The way this correlation product works is when you get particles that are much larger than rain, like you can start to get some debris in there, you get trees that'll be lofted, even leaves. Those are very high reflective particles that are very different in size than the little rain droplets that are going around inside of a mesocyclone. And that'll create a little circular area of near zero correlation coefficient between the particles. That means that you have a mix of particle sizes, a mix of small droplets, a mix of debris. Even hail can show up on this, but I'm not really seeing that very circular area right now, that well-defined debris blob that you would see. But boy, does it look intense. It looks like some range folding even with the RFD right tight up with that circulation. South of Oberon, northwest of Cheyenne. That's where the circulation that we are watching right now, and it is ramping up. Look at that thing ramp up. It's just sitting there spinning on the, as it's just getting seeded by those storms immediately off to the southeast. It even looks like it's trying to propagate a little to the east-southeast. Cheyenne, you want to be in your safe place. Oberon, you want to be in your safe place, because this thing is probably going to meander all over the place. It's going to meander northward, back southward. It might just sit there and spin down a little bit as well. But definitely some erratic vortex motion is going to be observed with relatively weak steering currents aloft. And you can definitely see this as an HP storm. Circulation south of Oberon, northwest of Cheyenne. A lot of convection as well, just unzipping all up and down the front. That's going to continue to happen. This is an intensifying supercell as well to the northeast of Devil's Lake, southwest of Lawton. Let's take a look and see how the rotation is progressing. Just a little bit of inflow of that storm. This tornado warned storm is getting more broad to the southwest of Edinburgh in North Dakota. Slightly more broad of a circulation. We've been watching the shear profiles as well out of Grand Forks. Kind of some marginal wind shear that's in place. And this circulation is quite healthy. This is a large mesocyclone. Definitely capable of producing some pretty large hail. Possibly even up to tennis ball size hail potentially as this thing has a mesocyclone. One thing that is consistent with storms is when they have a rotating updraft, they're capable of producing much larger hail than these air mass thunderstorms, even if they are in an environment of pretty big cape. But this is an HP storm, circulation embedded within that rain blob. This is northwest of Cheyenne, south of Oberon. We're watching that circulation very closely. That's where the circulation is. Tornado potential with that storm. Thank you everybody for tuning into my weather reports. If you know anybody out here in eastern North Dakota, be sure to share this stream. If you know anybody out here, be sure to share it. I'm breaking down this radar right now. We got a mesocyclone to the south of Oberon, northwest of Cheyenne. This is the 281, Highway 281, and that circulation is just west of Highway 281. Eventually, all these storms are going to congeal into a mass, and then that mass is going to slide off to the southeast with windbag potential as it moves across northern Minnesota. Here is the HRRR model, the latest one. Now this is the 12Z. We'll look at the latest one and see how it compares to this. But right now what we're seeing is the unzipping of this front. And you can see how they don't move very much. They just kind of unzip and interact with each other, and then eventually the whole complex bombs off to the southeast as a windbag as it moves through northern Minnesota. But you also get the development down closer to Bismarck. We're also seeing that development. This storm, if it's possible to curve into far southeastern North Dakota late at about 8 or 9 o'clock, that one could also have some potential of producing a tornado or two. But really what I'm seeing here is a major threat of a long-lived destructive windbag that's going to move across northern Minnesota, eventually arriving in the Minnesota Arrowhead by sunrise on Saturday, including Duluth, moving out over western Lake Superior. You can also see these storms over the southeastern corner of Manitoba, staying south of Winnipeg, but eventually moving into the southwestern corner of Ontario too. So the HRRR has done a remarkable job so far at forecasting this event. And look at our new couplet on our tornado warned storm just southeast of Oberon. Trying to tighten up again. It still looks like a couplet that's going to depend on mesoscale accidents and storm interactions there, but it looks like that's what it's trying to do, flipping some horizontal vorticity into the vertical halfway between Cheyenne and Oberon. There's the circulation. We'll zoom in on this a bit. Still no tornado that's in progress, at least according to radar. Still radar indicated, but that is a tight couplet. It is embedded within the rain too. Look where that couplet's located right there. In fact, we'll circle it, and then we'll head on over to radar reflectivity. And it does appear to be embedded within the rain, but it is pulling an inflow right here, right along that area of reduced reflectivity. It is trying to pull an inflow from southeast to northwest back into that circulation. Here you can see a bit of a wet RFD that's trying to bulge out toward the Cheyenne area, and you get those southeasterly winds back in toward that embedded couplet. Definitely is radar indicated, but boy does that look like it's tightening up. And you can certainly see the storm relative inflow coming in from the northeast. That's either strong inflow or range folded RFD around the south side. Very possible there's a good gate-to-gate couplet here to the west of Highway 281. Thank you everybody for joining me Please share this stream. We're just trying to keep people informed of the tornado potential here across eastern North Dakota. Breaking down radar as the Dominator 4 is broken down. Normally I'd like to be out here in the field chasing down these storms. The tornado potential did look a little bit marginal so far, but it doesn't mean that it only takes one tornado to cause big problems. And we have this tornado warning that's in place just to the southwest of Fort Totten. Still got our tornado warning up near Edinburgh as well. There's the Hook Echo wrapping around the south side. Edinburgh, excuse me. Not Scotland. But we have a dramatic weakening of the couplet and kind of a choke off of the inflow. That happens a lot when a lot of storms go up like this and start interacting with each other. The inflow is kind of limited up here to Edinburgh, and I'm not seeing much in the way of strong rotation anymore with this storm. Quite certain that this tornado warning is going to be allowed to expire. Short-lived mesocyclone that just blew apart. You can almost see it. The low pressure weakens, and then everything just, the wind fields weaken, everything just blows apart. It's no longer a very compact mesocyclone. This one is weakening as well, but it looks like it peaked just halfway between Oberon and Cheyenne. Possibly produced a quick tornado right there. I haven't seen anything in the way of a debris signature with that storm, but it may have produced a quick tornado, may have shucked a little bit of corn and then weakened halfway between Oberon and Cheyenne. There's the hook-like appendage around the backside. Hook-like appendage. It's still pulling an inflow within the weak echo region north of Cheyenne. Not yet, and I can show you the reason why it hasn't organized yet. And this is the wind shear profile at the radar site in Mayville. That's just south of Grand Forks, north of Fargo a ways. Basically, we have a straight line hodograph. And your surface wind is out of the southeast at about 25 knots. So you do have a 0 to 1 kilometer shear vector that is about 15 knots in length. That's just shorter than the 20 knot threshold or so, but you really need about 30 knots to have a robust tornado potential. With a storm like this, you've got about a 15 knot 0 to 1 kilometer shear vector, but you do have a lot of bulk shear, a lot of strong storm relative winds, especially with a due southerly mover at about 10 knots, moving very slow. You're going to have a lot of storms that are going to develop. They're going to congeal together. They're going to impede inflow. They're going to create mesoscale accidents. They're going to create outflow boundaries. They're going to split. You're going to have equal favoritism of the left mover and the right mover with a straight line hodograph like this. You need a curved hodograph, a strongly curved hodograph like that in the northern hemisphere, something like that, let's say. Strongly curved hodograph to favor the right mover. When supercells develop, they're basically turning horizontal vorticity into vertical, and you get two counter-rotating gyres. Rain falls in the middle. The left mover propagates way left. The right mover propagates to the right. And in the northern hemisphere, when you have the appropriate shear profile, as you'd expect in the northern hemisphere, with southerly winds at the low levels going up to westerly aloft, that type of a shear profile will encourage the right mover to dominate, and it kills off the left mover, usually. But when you have a straight line hodograph, the left split and the right split are equally favored. It doesn't mean that the left split's just going to produce a bunch of anticyclonic tornadoes, but it will exist a lot longer. It'll be a longer living storm. And yeah, your 1 kilometer, 2 kilometer wind are exactly the same. South-southeast at about 30 knots. We are starting to get an increased low-level jet, though, that is starting to be indicated by the Grand Forks radar. The 1 kilometer wind, 2 kilometer winds are now about to move past the 30 knot vector. And as you go toward evening, a little closer to sunset, 7 or 8 p.m., that 1 kilometer wind is going to even increase more, up to 40 knots. And it's possible that if we can maintain a discrete storm, which is difficult with this type of a situation, then we might be able to squeeze out some tornadoes. But looking at the RAP analysis, very meager wind shear out ahead of this developing convective line. You've got numerous storms slamming against each other, interacting with each other. The only decent wind shear is behind the cold front over Teddy Roosevelt National Park out there, National Badlands of western North Dakota. Even in southeastern Manitoba, very marginal wind shear. And that's why a tornado watch wasn't issued for this area, but a very high-end severe thunderstorm watch. It does look like you get a little bit of shear down near Fargo along the outflow boundary, though, by about 9 p.m. That could locally enhance the severe weather threat as these storms move down along this outflow boundary. You can see the changing wind direction due south along the western edge of the Red River, southeasterly to the east of it, even northwesterly out here. I mean, what a setup. But you do get 150 to 200 shear right along the Red River Valley near Fargo as those storms dive off to the southeast. And the RAP still tries to show those storms moving into southeastern North Dakota by about 9 p.m. Those could also have some tornado potential. But it definitely takes that supercell that is west of Grafton and just bombs it southward through the Red River Valley. And eventually it increases the low-level wind shear by 9 or 10 o'clock. Let's see if the convective inhibition builds in by then. And that blue color, that is the arrival of the convective inhibition. Between 7 and 9 p.m. it really starts to fill in. This area here, the hatch area, is very strong negative buoyancy. Any storm that moves into that air, it's not going to survive. A lot of times these north-south outflow boundaries will set up across the Red River Valley of North Dakota and Minnesota. And they're building back. And it looks like the forecast models are taking a couple of these storms. Maybe it's this Devil's Lake storm and curling it south-southeast along an outflow boundary. I believe that the models are taking this storm. Yeah, look at that. 2 hours, that's 5 p.m. That's basically right now. So they kind of dive that storm southward along the Red River Valley. I do want to take a look at the latest HRRR, the new model, and I want to see some forecast photographs. It's doing a pretty good job at analyzing the outflow boundary in the Red River Valley by 19Z. Let's go forward to about, that's too far, 22Z. Still hints at that outflow boundary in the appropriate spot up through the Red River Valley. The front in good position. Bubblers along the front. It's done a pretty good job here at forecasting the evolution of the surface boundaries. Get the timestamp in there, 22Z. It's 5 p.m. Central Daylight Time. One of the first steps of becoming a meteorologist is learning the conversion from Zulu time to regular time, or here, and you have to account for daylight, standard time, the different time zones. Zulu time is just Greenwich Mean Time, with midnight out there being about 7 p.m. Central Daylight Time. So as long as you can remember that 0Z or 24Z is equivalent to 7 p.m. Central Daylight Time, which is basically the beginning of the magic hour out there, getting a little bit closer to sunset when the wind shear ramps up. You just remember 21Z is 4 p.m., 18Z is 1 p.m., 12Z is 7 p.m., all Central Daylight Time. And then you can do the math in your head. For Eastern Time, you could subtract 2. For Pacific Time from Central Time, you could subtract 1 from Mountain Time. Then if you're going to Standard Time, you subtract 1 more during the winter. When it's Daylight Time, then you add 6Z's midnight, Central Daylight Time. So you got to do that math in your head on the fly, and the more that you do it, the faster you'll dominate. But even I was slow once upon a time math has always kind of come a little easier, but so you could definitely see these outflow boundaries, the one through the Red River Valley. Even another hint at a streamer of 0 to 3 kilometers that's streaming up into the Devil's Lake storm. This is the lead storm, but you can definitely see why these two have gone tornado warned is because of this horizontal pipe of streamwise vorticity and a 0 to 3 kilometer sense that's streaming toward those two dominant storms there. That's 0 to 1 kilometer EHI. Let's go forward to 0Z. Look at that pipe intensify. That's a pipe of wind shear up into the Devil's Lake storm. And this is at 0Z. What time is that, folks? 7 p.m. Central Daylight Time. So this is a pipe of some very favorable 0 to 3 kilometer storm relative helicity, southeasterlies, intensifying southerly low-level jet over top. That's at 7 p.m. That looks like an environment that is more supportive of tornadoes if this storm is able to maintain a supercellular mode. Click on a sounding near Mayville. This is a forecast sounding, a forecast photograph. But compare how that thing looks at the radar now. The photograph up here. See how it's more strongly curved? 1 kilometer wind, about 15 knots. Really, it looks real similar to what it looks like now. But with your 1 kilometer wind at 30 knots, it looks like a little bit more shear being analyzed between 1 and 2 kilometers. Still have some good upper level winds. But here your 0 to 1 kilometer shear vector is close to 20 knots, which is right at that threshold where there could be tornado potential. No cap, very moist. Southerly surface winds, a southwesterly low-level jet at about 40 knots. Flipping around to westerly, you got a 50 knot west-southwesterly wind in the mid-levels of the atmosphere. Very thick cape too. Big separation between the dotted line and the red solid line, meaning that your parcel is going to continue going up like a hot air balloon until it hits the equilibrium level. When the dashed line is equal to the red line, that's the equilibrium level, and those parcels will stop going up unless they have an overshooting top. Sometimes they'll penetrate into the stratosphere. But if you're able to maintain a discrete storm that's able to turn into that pipe of wind shear, And I do think that there's a decent chance of a tornado potential. If this congeals into a massive line that's heading off to the southeast, then you're probably going to have embedded circulations within the line, just because of that strong low-level wind shear that's feeding into that zone. And it looks like right near Mayville is where that's going to come together late. 8 p.m. we go to 9 p.m. By 9 p.m. it probably begins to congeal into a massive storms. But boy, it does dominate that supercell storm. The HRRR loves to just dominate that thing. Look at it. It's going to move right into that pipe of enhanced 0 to 3 kilometer shear. Right now it's developing up here. It's going to turn right and eventually propagate down the Red River Valley, eventually into northwestern Minnesota. Then this is going to become a dominant windbag and just plow across northern Minnesota, likely with a big straight line wind event. But even at 8 p.m., it definitely has more of a cluster situation. Then central South Dakota east of the Missouri River convex. This might turn out like a bow, but if this can hold on as a supercell storm, then look out. Look at that thing. That demon there approaching the Red River near Fargo. About 5 years ago, I was up here storm chasing near Mayville, and my plan, I was kind of at peak physical fitness. My plan was to try to golf 18 holes, run 10 miles, and intercept a tornado in the same 24-hour period. And I came very close to pulling off the Storm Chaser Triathlon up there. Woke up early in the morning, ran the 10 miles, and it was hot, very hot. And then I went to golf, and I had golfed about 12 holes the night before. So I went out to try to finish off the 18 just before the storms fired. And then I went out and chased and then saw 3 tornadoes northwest of Mayville. Saw a bunch of tornadoes. And then I got a migraine headache out of dehydration, I think, from doing all those things in the same day. Blasted down to Fargo. The Holiday Inn Express in Fargo actually has a casino in the same hotel, so there's blackjack tables and everything next door out there. So I went to Fargo, and I think I was so tired and exhausted that I ended up having a bit of a bender. I had like 2 beers and eventually got asked to remove I was removed from the casino up there, but I guess you could even call that more than a triathlon because I had the 4th event there in the Holiday Inn Express in Fargo. But look at that windbag that continues to push off to the east. This is a windbag that's going to go all the way across northern Minnesota, eventually arriving in the Duluth area by daybreak tomorrow. I thought initially, I was wondering if that storm was going to have a chance of producing a tornado as it moves into southeastern North Dakota, but I'm not as worried about that storm. I'm much more worried about this one now, that it's going to be able to mature up near Devil's Lake and then turn off to the right and then ride into that outflow boundary off to the southwest. Let's go back to radar again. Real-time radar breakdown. It's great to see so many people breaking down radar these days. It's definitely not... I'm a natural storm chaser at heart, of course, but I've been looking at radar for like 25 years, and even before then, before I got my driver's license. So eventually you start to learn to see the patterns in radar. You start to be able to storm chase based on radar as well. One time I was at this New England Weather Symposium, the National Weather Service, to do a speaking event during the Storm Chasers days. And the WCM up there, I think it was Taunton, or up in the eastern Boston area, came up to me and he was all cocky. He's like, I'm going to try to pick out the couplet out of this radar image. And he thought it was all complicated and I wouldn't be able to do it. But I looked at it and it was real obvious. It was just right there. It was a rain wrap situation, but the couplet was really obvious in velocity. Picked it out in like 10 seconds and everybody kind of got all quiet. I think they were trying to embarrass me on the spot at that conference, but generally storm chasers are probably the most effective interpreters of radar than anybody out there. Our livelihood depends on being able to identify where storms are going to happen, be able to anticipate tornadoes as well. Of course, we don't have to warn for a whole entire county warning area. There's very low stress because we're just trying to pick out where the tornadoes are going to happen in advance. But right now, just eyeballing this, I'm not seeing any pop in storm relative inflow up ahead of these 2 storms. Even on our original tornado warned one to the west of Grafton, you could just tell that they're feeling the effect of a weakened low-level jet. You're not seeing that huge storm relative inflow pipe just to the east of these mesocyclones. Just not seeing it right now. But this is the dominant storm southwest of Devil's Lake. I think what's going to happen is this storm is going to drift into the stable air, probably will die along with these storms. And then this dominant storm southwest of Devil's Lake has the chance to turn right and then ride that inflow zone. Big outflow boundary, big outflow pipe that's coming in. Definitely has a chance to turn southeast. These storm chasers are probably going to overshoot, end up north, and then this one will drop down behind them and go tornadic. See how the rotation is. It's just in the northeast of Cheyenne now, but it's relatively broad. Just crossed 281. This is the area that we're watching for tornado potential, just east of Highway 281 there. You can see kind of a broad couplet, some westerlies on the south side. I'm not seeing any bright colors with the storm relative inflow coming into that, but that circulation just east of Highway 281 there. Broad circulation, still tornado warned or radar indicated. I doubt if there was a report from this velocity scan, I would deem that a fake report. Just because I know what's likely happening underneath that storm. Let's take a look at echo tops, and especially the time series of these echo tops. And look at the echo tops are starting to subside on that storm. Coming down. It's losing its tornado potential. This one's ramping up now, and it's going to seed the hell out of the tornado warned storm out near Manfred. Looks like we're trying to get a little mesocyclone that's going to peel off this zone near Manfred. Not seeing much in the way of rotation on that storm, but relatively broad. Really happy. Morale is high because we had some homemade chili dogs last night and today at lunch. Nothing is better for morale than the chili dog. So you've got a pipe of 0 to 3 kilometer shear streaming up in this zone. You've also got a pipe of shear streaming in this zone. And it does appear that the models have picked up on this enhanced 0 to 3 kilometer storm relative helicity in these couple different pipes. We saw them on the models. We already broke it down on the HRRR. I'm going to show you again because I'm obsessed with using this as a forecast technique. I usually use it for the high plains, but for these kind of diffuse setups like this, it's also a very good method to use. And you can actually see a couple different pipes, 0 to 3 kilometer shear pipe along the immediate outflow boundary, and this one that's streaming up into the Devil's Lake storm. That's why it's been dominating. This is at 6 p.m., about an hour from now, as these storms are maturing in a convective line across northeastern North Dakota back toward the central portion of the state. Good wind shear streaming up into these storms in eastern North Dakota as well. Photographs are a little bit compact, but not bad. They are supportive of a low-end tornado potential, even though your 0 to 1 kilometer shear vector is only about 20 knots in length. It's all about the length of those low-level shear vectors, and they need to be properly aligned. A critical angle of about 100 degrees. Closer to 90, that's pure streamwise vorticity, but if you're at a little over 100 degrees, that'll work too. But you really want a low-level jet up here near 40 knots too. Have a really robust tornado potential that's not dependent on mesoscale accidents and whatnot. But you do have some big cape out here. You've got outflow boundaries. You've got interacting storms. You got very steep low-level lapse rates. You've got dew points around 70. Strong directional shear in the low levels. So the ingredients are in place for mesoscale accidents to happen. So they are a little bit more predictable than you might think. There's that environment down in Nebraska that has my eye. Looks very similar to yesterday's environment, except you don't have the upper support. A little bit of a subtle jet down there, but you just don't have that strong high pressure, that ridge rider. You do a little bit though. Those are 25 to 30 knots out there, but this is the upper level storm system that is causing the eruption of severe weather up north. Jet streak here that is nosing into the central Dakotas. Usually the left exit region of a jet, the left exit region is where you get the most lift. So as that left exit propagates over the region, That's going to provide the lift that's going to fire those storms along the surface convergence of that southwest and northeast oriented front. Left exit is moving right over that corridor in northeastern North Dakota. It's a positively tilted trough, the main trough back in Canada, the main belt of westerlies into the Canadian prairies, and it's this subtle lead impulse that is firing the storms today. We've got a surface map out here. There is a little bit of dryness here. Look at that. That's going to be an issue. Some mixing in the Red River Valley. You got some lower dew points into the low to middle 60s across the Red River Valley, and then you've got this pipe of 70s dew points to the west of it. Stable air across northern Minnesota. You do have these upper 60s dew points streaming in through central Minnesota. Those will arrive in time for the windbag late night tonight. But I would target this pipe of low 70s dew points. I think you need that moisture, and you need the storm to turn southeast and propagate into that deeper moisture, and that's going to require those dew points into the low 70s, certainly. I think that these drier dew points are starting to kill the furthest northeast located supercell. Still got, that's killing these storms. These are starting to die and look a lot more elevated. Severe thunderstorm warning continues up there across northeastern North Dakota into northwestern Minnesota. This storm southwest of Devil's Lake. This is the one where that pipe of low 70s dew points is streaming up into. That's east of Cheyenne, east of Fort Taunton. But the circulation is getting much more broad. So this tornado warning is certainly going to be allowed to expire in 3 minutes, I bet. Of course, I don't want to anticipate what another human or a National Weather Service elite forecaster is going to do. But I think that this is getting more broad. And the echo tops are coming down. Got a new tornado warning for our next echo top down. Manfred. Not seeing a ton of velocity. Reflectivity does support a hook-like appendage southwest of Manfred. A little bit of a weak echo zone showing you the southeasterly inflow as well. But there's your hook echo near the Manfred area. Not seeing a ton of rotation on this storm. Let's try a different radar. I mean, these are a mess. Maybe just west of Fessenden, you can see a little bit of rotation. We're scanning higher up in the storm. We should see a deep mesocyclone, certainly even from this angle. The high echo tops do support a rotating updraft. Looks like they're warning this radar artifact, but probably this inflow back to the southwest of Manfred. Broad circulation out there. But heed the warning, Manfred, Fessenden, get in your safe place. That's along the Highway 52 corridor. Tornado warning has been issued out here. We're using the Bismarck radar. There it is, Manfred and Fessenden. Let me do a quick post on that. If I'm not chasing, I want to warn people in the path of these storms. And we have a new tornado warning that has been extended for the Cheyenne storm. So we got 2 tornado warnings, 2 live tornado warnings, and we did have that tornado warning extended for the Cheyenne storm. That's out here. Looks like that one could be moving into that more favorable environment. The next scan must have gotten more substantial with its rotation. They are warning everything. I'm not seeing a ton of rotation with this storm right now. I do think that it is capable of producing some land spout tornadoes along the shear zone But this new tornado warning has been extended east. The hook-like appendage is trying to propagate off this convective line. If this thing continues to propagate into those low 70s dew points, it will have a chance of producing a tornado. Hail size less than 3/4 of an inch. Very small hail, interesting. See if echo tops have come back up with this new scan. Echo tops are quite low, so it does appear to be a storm that's maybe split. I mean, on reflectivity, it looks pretty substantial with a hook that's coming down. Velocity, it doesn't look that intense. I got to do this post for the new tornado warnings really quick. Bear with me, everybody. Thank you for tuning into this live weather report. We are dominating. Thank you for helping us to be dominating. Share this if you know anybody in eastern North Dakota. Jeez. We're going to be doing this live radar breakdown until the tornado threat really wanes. It is 21Z right now, isn't it? 4 p.m. Live with 2 tornado warnings in Northeast North Dakota. All right, guys, we are going to stop and start the Facebook stream really quick. Turning it off and then turning it back on. Sometimes you have to do that every now and then. So this is the tornado warned storm. This is Cheyenne with an S in North Dakota. This is the Highway 281 corridor. This is a weak echo region where it's pulling an inflow, and it is developing a nice hook-like appendage on the backside. The latest scans may start to show some increasing rotation. In anticipation of that, I do agree with the tornado warning to be issued. Even though the couplet is still relatively broad, that could come together quite quickly. The original tornado warned storm further northeast near Edinburgh and east of there has weakened. That's the one to the northwest of Grafton, and that has been replaced by a large severe thunderstorm warning. This circulation eventually is going to head off to the southeast. This storm is out near Cheyenne. But there's the hook-like appendage. Rotation is still relatively broad on it. You can see that the echo tops are starting to come down, but this storm has split. You can use the echo tops and see that a left split's lifting north toward the Highway 57 corridor. Right split starting to increase. Echo top starting to increase east of Cheyenne, east of Highway 281. But just not seeing that tight couplet yet. Just really broad. Let's start using some different radars. Also the tornado warning at Manfred and Fessenden that we're tracking. Kind of some diffuse rotation southwest of Manfred. Weak gate to gate shear out here. You could call that a broad couplet as well, but the tornado warning continues for Manfred and Fessenden. Get in your safe place. Respect that tornado warning. This is the Highway 52 corridor. Those two towns from Manfred and Fessenden are included in that tornado warning in red, but this is the couplet. Just meandering back there. It's not moving very fast. Just sitting to the southwest of Manfred, but it is trying to move off to the north a bit. Now that storm could impact the Manfred area later on this evening as it lifts off to the northeast. We'll have to keep an eye on that circulation. Right now it is relatively broad, but if it continues to head off to the northeast, Manfred could get impacted by that circulation. Certainly not seeing any debris right now with a couplet that is that broad. But it could tighten up very quickly too. That's probably just some little hail that is within that storm. And you can still see that the gradient and reflectivity on the south side is a little bit chunky. You definitely got a hook echo on the southwest side out there. But convective line tightening up. This is definitely the most dangerous storm to the east of Cheyenne. It's got a little bit of a hook that's popping out of it. You can also look upstream on radar and see this outflow boundary extending off to the south-southeast. It's possible this storm could anchor on this boundary. There's some kind of a boundary here, maybe a moist convective roll. And looking at the surface map, this boundary has like low 70s dew points. So if the models are right, then this tornado-warned storm is going to start propagating off to the south-southeast, moving right along that pipe, that 0 to 3 kilometer shear. Looks like you even got a tower trying to develop along that boundary. So that storm is probably going to peel off the line and turn south-southeast, eventually toward Gray City, Glenfield, Kensal, Courtenay, Wimbledon. That'll just continue to head off to the southeast. Can definitely see the inflow that it's pulling in. You can see the RFD that is bulged out a little bit and is trying to pull in inflow. Definitely has a nice weak echo region within that hook. East of Cheyenne, pulling in some good inflow into that storm. Wow, dominating. We are going to be rolling out some support badges too, some Team Dominator themed badges that are going to be coming out and emojis. So we are handling all the detail-oriented stuff here of being one of these YouTubers. Excited to show you that as well. Let me loop this and see if we can start to see hints that that storm is starting to anchor. You can start to see it. Look at it lift north into line, and then it's starting to propagate more of an east in an east-southeasterly direction as this whole thing is starting to turn into a massive line. It's possible, though, that these supercells will just kind of gradually peel off this convective line, and we'll see these occasional tornado warnings as the convective line continues to drift south. This one's trying to consolidate southwest of Lawton, but it's definitely more of an elevated storm, elevated supercell, west of Lawton, west of Brockett. This is by far the more dangerous storm out here near Cheyenne, east of there, east of Highway 281. But very broad rotation. You can kind of see a little hint at an RFD bulge around the southern edge. You get some more westerly winds out there. Watching to see if we can pull some storm relative inflow, a little bit more of those bright red colors, and on the east side of this storm. A very broad rotation on this. If there was a tornado, it would be located probably about 5 miles east of Cheyenne, but you'd see a lot more of those bright colors right next to each other. Still radar indicated. Tornado warning back to the southwest still includes Manfred, Bassenden, and you can start to see this supercell structure. Not seeing as much of a hook-like structure, but I wouldn't be surprised if this pops out a little hook-like appendage on the south side. That's good. Thank you for doing something. I feel like I'm doing something as well when I do these live radar breakdowns. Even though it's a lot more natural for me to be out in the field, I still enjoy doing radar breakdowns as well, breaking them down for you. Thank you, everybody. Hit that notification bell if you like what you see, if you like my weather reports. Hit the notification bell also if you prefer me to be out in the field storm chasing. Or watching that tropical wave out deep in the Atlantic that could be an issue. But this thing is pulling in some storm relative inflow on the east side. That's the hook echo. That's the weak echo region in the middle of it. So it is definitely trying to pull in and wrap that around and conceal a bit of a circulation right in there. And it does look like we have a little bit tighter of a rotation coincident with that weak echo region as well. Kind of a broad circulation that you're seeing there. So not incredibly tight circulation, but east of Cheyenne, if you're in that area, definitely. New circulation ramping up on the northeast side of that warning, interestingly. So it looks like this is becoming the dominant hook. This is west-northwest of Warwick. Possible that this has more unimpeded inflow, but it looks like this is a supercell, this is a supercell, and actually the stronger rotation is in the northeast edge of that tornado warning. Up into that area, southeast of Fort Totten. A couple of hooks. Got this hook-like appendage, got this hook-like appendage wrapping around. So two circulations that are developing within this tornado warning. Both of them have circulations that are quite broad, but you can see that this one in the northeastern corner of the tornado warning is now a little bit stronger, and that's kind of a new development. Look at that thing develop and move east-southeast. I think it is going to head toward the Warwick area as it propagates east-southeast. Upper level flow isn't enough yet to spin these storms off of this and then propagate them away from the convective line. That tells me that this line is probably going to congeal into a squall line that's going to slide off to the east-southeast. This one's dying out near Brockett. It is trying to regain access to the unstable air. A little bit of a mesocyclone to the west of Lawton and Brockett. A broad mesocyclone up there. A lot of poutine and cheese curds up in this area too. Being this close to Canada, I know that there's a lot of access to poutine even in this area. And it looks like we might even have a little bit of a mesoscale accident trying to develop in the northeastern corner of this tornado warning, west of Tokyo, North Dakota, southeast of Fort Totten, southwest of St. Michael. But that's probably more of a radar artifact. I'm not really seeing a ton of robust storm relative inflow that's feeding into that. You'd usually see more of a debris drop that would happen. You'd see a correlation drop. What is that? Yeah. These are way too broad, these circulations. Way too broad, everybody. But we are dominating still, breaking down these tornado warnings as they come in. We'll take a look at echo tops and see how high these rotating updrafts are penetrating into the upper atmosphere. And this one's starting to really peter out east of Cheyenne. We're really starting to lose the echo tops. The Manfred and Fessenden storm is dominating. Still got 50,000 foot tops down across that zone. Echo tops are collapsing across northeastern North Dakota. I wouldn't be surprised if this Fessenden storm turns southeast toward the Carrington area a little bit later. Definitely have a big convective line. But right now, northeast of Devil's Lake, this is kind of the cutoff. To the northeast of that, you have a lot more stable air, stable low-level air, and in the Red River Valley, those dew points drop into the middle 60s. But this pipe that's streaming into this storm, you can even see the thing convecting, that horizontal convective roll that's trying to convect down there. That could potentially show this storm its path. It could show its highway. That dominant storm could turn off to the south-southeast, move into that 0 to 3 kilometer shear, eventually heading toward the Valley City area. Oh, wow. Oh, yeah, look at this. Oh, wow. So the hodograph down in Mayville is starting to get more conducive for tornado potential. Surface wind still southeast at 15 knots. And I think your 1 kilometer wind is still near 30, but it does kind of have this general hodograph curvature, even though your 1 kilometer wind is still just shy of 30 knots. You need that 1 kilometer wind, I think, to surge above 30 knots, even push 40 knots to get a more robust tornado potential, an environment that's more supportive of tornadoes out ahead of that storm. Holy cow, there's been a tornado report. It's got to be a land spoot. Brief tornado 9 miles south-southwest of Manfred. Last 3 minutes. Moving north-northeast. I bet... Oh, that is probably what triggered the warning back near Manfred. That's this storm back here. Did produce a brief tornado that lasted for about 3 minutes. It wasn't on radar. Makes me wonder if that was more of a landspout type of a tornado to the west of Fessenden. Right now, the Cheyenne storm is starting to look more interesting. It's definitely starting to get a hook-like appendage. Let's see if the velocity signature supports it. Not much. Not very strong rotation with that storm. But you can still see on reflectivity that it does have that hook-like appendage associated with this bulge, a little RFD bulge right there, trying to pull in some inflow. Cyclonically curved hook, cyclonically curved reflectivity gradient. Flash flood warning out here. But this is where that tornado happened, just south of Manfred, or far from the storm, radar site-wise. There's kind of in a radar hole there. Bismarck is relatively close. Maybe a circulation down there south of Manfred. Kind of a broad-looking mesocyclone, but I wouldn't be surprised if that was a land spout tornado down here, right along the stationary front. It was a pretty mature supercell storm, though, that had very high echo tops. But the echo tops have since come down, and now we've got this flash flood warning. Look at the echo tops rocket. And that's probably when the tornado happened, as those echo tops are rocketing up, and then it just dies out. So rockets all the way up to about 60,000 feet, and then peters out. Just a quick demise on those echo tops. You still have decent echo tops up here near Devil's Lake, as we're trying to look for the dominant storm that might come out of this mess. But it's probably going to be more of a windbag circulation. You've got this large severe thunderstorm warning across northeastern North Dakota. Some pretty high echo tops back near Manfred, Fessenden as well. Flash flood warning in effect for the next 3 to 4 hours. 3.5 inches of rain had fallen, an additional 2 to 4 inches of rain possible across northern Wells County. Fessenden, Heimdall, Bremen, Manfred, Hamburg. Watch out for flash flooding. That might be the most dangerous part of the storm. Echo tops have completely evaporated across the tornado warned storm east of Cheyenne. This is northeastern North Dakota, everybody, if you're just joining us. Yeah, not a ton of rotation on these storms. I do want to see what this looks like on satellite. The eruption of storms, the unzipping on satellite. Oh, wow. So look at these storms just erupt. Anvil's just taken over. The anvils are spreading out, dominating. You can see these two boundaries on satellite. This one near the Red River, and then this one that's starting to peak in eastern North Dakota, where these low-level clouds show. That also shows you where there's surface convergence or surface moisture, even surface vorticity. And you can definitely see these two streamers that are streaming up into the convective conglomerate. 0 to 3 kilometer storm relative helicity. Big time Cape as well, streaming southeast to northwest. This eastern one streaming through the Red River Valley has dew points that are more in the middle 60s. This one, a little bit further west, has dew points into the low 70s. You can also see an eruption in central South Dakota as those storms are going up. And watch this thing just back build all the way back down. Beautiful. And you can even see those individual overshooting tops. Look at them. When they go up and then they get tornado warnings, they'll poke up into the stratosphere and then they'll come back down as they collapse. Just a lot of storms that are competing with each other and interacting with each other. First we saw these go tornado warned, then we saw these, and now they're just kind of propagating back to the southwest. Beautiful overshooting tops there across northeastern North Dakota. Brighter colors. colder cloud tops extending higher up into the atmosphere. And look at those little overshooting tops, those little turrets up there. Northeastern North Dakota. Just incredible. And they're not moving very fast. That's how you can tell the upper level winds are relatively weak. They're just kind of propagating, bouncing around a little bit. You can even see little wake glows. Look at in the wake, almost like a shadow-like appearance. A little bit of a suppressed echo top, but you can kind of see almost like a shadow-like appearance with this new satellite imagery. Clearing out way down to the south and getting suppressed, anvils expanding. So I think we're seeing a potential shift toward more of a windbag event with this with time, even though they are back building a little bit closer to Bismarck. Flash flood warning remains. That's going to remain for another couple of hours, but hardly any rotation with that tornado warning. It looks like we have what potentially, even though we're on Minot radar, probably the cloud shield, edge of the anvil. This thing is turning into a big time windbag. So we lost the tornado warning storm. That one has been suppressed. This one north of the elbow, we're starting to get the formation of an elbow here. Definitely getting the formation of an elbow. Strong westerly winds right behind that elbow. I don't think that there's strong enough easterly flow to just have this hook just bounce out and then become a mega tornado producer. I think what we're seeing is a transition from a supercellular mode to more of a windbag. We call this growing up scale when you go from the individual storms up to a mesoscale convective system. That's growing from a smaller scale, that is storm scale, up to the mesoscale. So we're growing up scale. We're getting larger in size, larger in the convective organization here. And what we're seeing now is a conversion to a windbag. Northeast of those tornado warnings, northeast of Devil's Lake, dominated by stable air up there in the northeastern portion of North Dakota. Further southwest, these storms are interacting with each other. Reduced low-level wind shear. But you can see that this whole elbow is going to want to propagate down south eventually on this shear pipe. But right now I'm not seeing anything in the way of very strong rotation, but we are starting to see an organization of a windbag here. An elbow event, strong, damaging straight line winds are starting to set up north of Warwick all the way up to Devil's Lake. Definitely seeing rapid generation of a windbag here. Mega shelf forming. If you're heading west on Highway 2, you'd definitely be able to see that mega shelf begin to develop. Look at it. Look at it come together. This is the development of a big time straight line windbag event. We do have a new mesoscale discussion that just came out. Actually mentions the windbag threat. So there's a new mesoscale discussion by the Storm Prediction Center. Right over the severe thunderstorm watch. Threat for damaging winds increasing with time as the trough moves through the region later today as storms congeal, create a cold pool, of course. Damaging wind should continue to increase in likelihood over the next several hours. Storms will have greater eastward push as the trough continues eastward into the region. Some gusts might even exceed 75 miles an hour. Brief tornado or two possible with new updrafts along the boundary, but we're starting to lose those new updrafts, and those supercell storms are congealing into a mesoscale convective complex. Initially, supercellular storms, northeast, central North Dakota, have fairly rapid growth upscale into a linear complex along the surface warm front. I haven't really seen much in the way of very large hail that's being produced. Given the current storm mode, tornadoes will likely be brief, but are most likely along the boundary where there's pre-existing vorticity. That's definitely consistent with, of course, what we're saying. Same for the last hour or so here. Great forecasters out there at the National Weather Service, Storm Prediction Center. A lot of them are my friends out there. Some of them are haters even, believe it or not. Roger Edwards is a long-time worker at the SPC, and back when I first started storm chasing in my late teens and 20s, he devoted a whole entire website that just ripped on me It was pretty intense. This day and age, stuff like that wouldn't be allowed, but he started a website and had a blog on there, and just about every single post was just ripping on me as a new chaser. The old chasers back then weren't as open to new chasers coming into their hobby. They'd kind of be like, oh, what's happening to my beloved hobby with all these storm chasers out in the field? Now the older chasers, like myself, were a lot more welcoming because of how we were treated back then. You know, it's good, I think, to be nice and not be a gatekeeper when you're talking about storm chasing like this. There are a lot of storm chasers out in the field, but when we were shooting storm chasers, there were a ton of them then. I mean, we had like 30 or 40 cars following behind the Dominators back in the day. So we're starting to get more stable air across northeastern North Dakota. That's what's killing those storms as we're starting to transition to more of a windbag event. Look at that stable air up there. The blue hatch area is negative Cape. This is Cape, positive Cape. Negative Cape is also called convective inhibition. And you've got those bright blue colors from the northeastern corner of North Dakota and across northwestern Minnesota. But you've got a Cape blob sitting off to the south, and you have some bulk shear, and you have increasing low-level wind shear out ahead of these storms as we get toward later in the evening, setting the stage for a long-lived windbag that eventually is going to start moving east as the trough ejects. And we'll probably move across central and northern Minnesota, eventually arriving to the Minnesota Arrowhead by tomorrow early morning. Very meager wind shear. Some along the boundary, you are getting some surface vorticity. And you can see the bright blue contours co-located with low-level Cape. Definitely showing you exactly where the co-location of surface space, low-level Cape, and surface space spin is located. And you get spin along these boundaries because you have cooler air on the cold side and you have warmer air on the right side. And that naturally creates horizontal spin along the boundary. And you get one of these storms that'll move along that boundary as well. Any of these updrafts, they move along that boundary. They'll stretch that horizontal spin into the vertical, and that's when you can possibly get a tornado. Notice how we lose the low-level Cape, though, from the in the Red River Valley and areas off to the east. Looking at the surface map, dew points drop into the low to middle 60s across the Red River Valley. This stronger low-level Cape, low-level shear here kind of represents those low 70s dew points and an abundance of surface heating. It's possible if you can get a storm on the southern periphery of that line to turn hard right and intensify, that it can move into that more favorable environment and potentially even produce a tornado. We get some land spoots out there in the Green Bay area too with a lake breeze, but no, probably not. Upper level winds are only 25 knots out here. That's a big issue, but here is the trough finally starting to eject. It's arriving late, but you've got some 40 knot winds that are starting to nose into southwestern North Dakota. And as these stronger winds start to move over top this convective line, it should start kicking some of these updrafts, the taller updrafts, faster off to the east. And that might help to eject the cold pool into eastern North Dakota, eventually across northern Minnesota. Looks like we got some backing across north central North Dakota. We analyzed that early on too. Wonder if you could get a little sleeper setup down across central South Dakota, maybe up toward Aberdeen. Ahead of this cell that's starting to erupt across north central North Dakota or South Dakota. Maybe as this spreads off to the east through evening, as it gets a little closer to Aberdeen, that could do something. But right now you got this stagnant convective line that has like 20 to 25 knot 500 winds. Basically near calm surface winds on it, but it's on the northern gradient of a big Cape blob. And that has allowed some, and because of the bulk shear, marginal bulk shear, it has allowed some supercellular structures in the presence of that large Cape to evolve. There's our windbag. Our tornado warning continues back toward the Manfred area. But that's got to be allowed to expire too. There's a new storm starting to go up just to the southwest of it. This one right now that's developing just north of Highway 200 on the tail end of all these storms. This one has the greatest potential now of producing a landspout, maybe a quick tornado. Storm relative inflow is still very lacking, but we also got to go to the Bismarck radar. There's the old circulation lifting off to the northeast of Manfred. Apparently that produced a brief tornado southwest of the Manfred area, that circulation there. Tracking it off to the northeast. It looks like it probably produced, maybe right there, southwest of Manfred by about 10 miles. And it also looks like there was another circulation near Manfred that tried to produce, and now that circulation has been blown apart. No tornado warnings now in effect. Flash flood warning, Manfred to Hamburg, Bremen. Big time rain, and we're watching this new storm that's developing. It's just to the north of the Highway 200 corridor. Watching that one for intensification now. This cluster, this conglomerate could also become a supercell storm. But this one's transitioning to a windbag just south of Devil's Lake. Look at this boomerang here. Big winds happening. Potentially gusting up to like 75 miles an hour. But yeah, there's the windbag coming up to the Highway 2 corridor. If I were chasing this windbag, I'd be heading west on Highway 2, targeting the elbow that is punching off to the northeast, east of Devil's Lake, west of Prairie. That's where the elbow region would be. Maybe a little circulation on the backside, but some enhanced southwesterlies there. Sometimes you can get a little bookend vortex that can develop. That's just southeast of Devil's Lake, but this area, nosing up to Highway 2, those are the most intense winds right now. 70, potentially even 75 miles an hour, punching up into Prairie. Warning statement says 60, 70 mile an hour winds further northeast for that massive severe thunderstorm warning up there. So this thing is transitioning into a windbag, everybody. A lot of severe thunderstorm warnings over the southeastern portion of Canada, but very disorganized convection out here. Not even any supercellular structures, just some big straight line winds out here. Maybe some marginal hail as well. Southeastern portion of Manitoba. All south. Well, we got another bubbler pretty close to Winnipeg. Look at this thing. I wonder if that's a split. Whoa! That fired on the outflow. Look at this outflow boundary that came from these storms over southeastern Manitoba. It sent out an outflow boundary, and that has prompted a severe thunderstorm warning that's pretty close to the south side of Winnipeg. Possible large hail associated with that. Maybe some winds gusting up to 60 miles an hour. These are elevated storms, so the tornado potential is basically zero with these storms. Northerly surface winds. You're getting these northerly surface winds in a post-frontal environment up here. Flash flooding seems to be the biggest threat with these. And it's already an area where the soil is saturated. You've already had a bunch of river flooding out in this area. So this conglomerate of precipitation is probably going to cause some flash flooding. Big flash flooding happening up in that area. I do want to take a look really quick at the forecast QPF through this evening. Here's a wrap analysis showing a very weak shear along that boundary, but an environment that does have some potential for brief tornadoes due to the surface vorticity along the boundary, the blue contours. Thank you, everybody, for tuning in to this weathercast. If they continue to congeal together like this, stay with us. Definitely stay with us here. It might turn into a big, long-lived windbag event. The HRRR definitely shows most of the rainfall falling right now as this boundary is stationary and before the trough arrives. But this is QPF showing you those several inches of precipitation over the 10-hour period, but maximized across this zone where we do have some flash flood warnings. You can see that little pocket too over southeastern Manitoba. Probably will be some flash flood warnings up there as well. And some of that precipitation does move into the Winnipeg area. Continues to propagate northward despite those northerly winds. And then we start to get some decent precipitation as the wind bag accelerates, moves off to the southeast. Let's see what some of the other models are showing. 3-kilometer NAM. Probably more representative, but it also shows this heaviest rain right in this zone. I think that the 3-kilometer NAM did a better job with the magnitude of convection just unzipping along this stationary front from Bismarck all the way up to the northeastern corner of the state and into the southeastern corner of Manitoba. Shows a pretty big rainmaker here across the northern plains tonight, and I do think that that probably could be one of the main threats in addition to the straight line wind is going to be this rain out here. Big rain happening, flash flooding northeastern North Dakota into southeastern Manitoba. 3-kilometer NAM did not do a very good job though with the mixing out of the dew points that it has been analyzed across the Red River Valley. Even the HRRR has not done a very good job at initializing the dryness that is found. The 20Z HRRR does a little bit better job mixing out those dew points. Western Minnesota, stable air dominating northern Minnesota. There's your wind bag coming together in the models. Stepping forward to 8 p.m., the wind bag slides through the Mayville area, northwestern corner of Minnesota, continues to propagate southward, and actually gets stronger winds a little bit further south. There's your wind bag, folks. Hope you're satisfied. This will be the dominant wind bag. You'll also get a wind bag that's going to form through eastern South Dakota. This is that Aberdeen one that might be able to latch on to some kind of a boundary in northeastern South Dakota with those easterly surface winds. Who knows if that'll be able to do a mesoscale accident. So this is definitely transitioning into a straight line wind and even a flash flood potential. You can see that storm interaction is starting to lead to the demise of some of these storms. This boomerang shaped big unit here is definitely a straight line wind threat. Maximized along Highway 2. Prairie to Bartlett is getting some good wind. Notice how these hooks on the south side are just really losing their robustness. They're not latching on to the good surface winds anymore. Not latching on to that moisture. These ones are dying to the northeast. Brockett, northeast of that as well. The one near the Red River, almost completely losing its identity. And you can see the culprit. Look at this outflow boundary surging off to the south. Big outflow, choking those storms off from relatively warm inflow. You're going to get stable air, northerly stable air on the south of that. Maybe this storm right at the leading edge of the outflow will have a chance to latch and then turn off to the southeast, but I really doubt it. These are really having trouble moving off that boundary. Eventually, the stronger stronger southwesterlies in the mid-levels are going to be coming in with that upper trough, and it's possible you could get more cold pool generation. We do have a severe thunderstorm warning now for that storm north of Pier. And the surface map does show more in the way of easterlies down here. This is southwest of LaPlante, west of the Gettysburg area. And boy, look at that. A little bit of rotation with that too. A little RFD structure. Definitely some rotation. 2-inch diameter hail with that thing down there. That is across north central South Dakota, west of Aberdeen, southwest of LaPlante. Probably the strongest storm out there right now. Dropping very large hail up to 2 inches in diameter. Look at that echo top as well, going up to 60,000 feet. You got to be kidding me with that. Thank you, Twitch, for joining us. Thank you, Facebook, for joining us. I think we're getting a little bit throttled by doing the restream, so I might have to go back to streaming to the individual platforms again. It's also possible that this location in the north, the population density is a lot lower. But I do the breakdowns out of my own personal enjoyment. Here's Highway 212. Echo top's just to the south of Highway 212, maximized. This thing has the look of a big-time hail producer. Southwest to northeast winds, you get the formation of these two wake eddies downstream, giving you the flying eagle appearance to this storm. Eagle head down here, the two wings on each side. And it's just like a rock being embedded in a stream. The stream flowing by it. It creates two counter-rotating gyres downstream of the obstacle. And that's exactly what you're getting here. The obstacle being the supercell storm, basically like a boulder. Also have severe thunderstorm warnings down to the west of Winter, down in the pheasant hunting capital out here of the world, I think. So we definitely do have some supercellular structures developing into south central South Dakota that are starting to mature as well. Some couplets on these, just east of Mission, South Dakota. Northeast of Whitehorse, a broad couplet, possibly some pretty large hail with that. Warning statement says 1.25 inch diameter hail, but it does have a mesocyclone that is a supercell storm down there, right along Highway 18 east of Mission. This one has a higher echo top. This warned one northeast of White River, 1.5 inch diameter hail possible with that storm. Sliding into that new severe thunderstorm warning. South central North Dakota. Storm north of Bismarck is now warned, severe thunderstorm warning. But this one's kind of a low-end echo top, kind of a messy-looking storm, post-outflow boundary type of a storm. There's the outflow boundary, so it is on the cold side of the outflow boundary. That might actually help increase its hail size if it can get into some of those northeasterly surface winds. Hook-like appendage here on the southwest side. But that is the unstable air anywhere south of that outflow boundary. Maybe that storm can latch onto that boundary and stretch some of that horizontal spin into the vertical. 1 inch diameter hail with that storm. That was definitely starting to feel the effects of the trough a little bit. Notice how it's starting to propagate a bit more. There are really two reasons for the faster storm motion of this storm. It's starting to feel the stronger mid-level flow from the approaching trough off to its southwest. And we got a tornado warning here. Look at that hook-like appendage that has reached out. Oh. Out near the hammer area. A little bit of a circulation. RFD bulge as well. Bulging out near hammer. Looks like Vince is on it. Big westerlies coming in here. 70 miles an hour. That's the circulation. Hamar. Get in your safe place. Radar indicated circulation. Very small hail. Interestingly, that formerly suppressed hook is now kind of punching out a little bit. God, this stupid thing. There we go. There's the hook. Just could not get that warning statement out of the way. So there's the hook-like appendage that's coming out of this mass. Kind of surprised this is happening. Look at it reach out. There's the outflow boundary bulging out from this lead windbag up north of Michigan City. We're still in northeastern North Dakota. This is incredible. Look at that boomerang, and then the thing is reaching out. Definitely could be some landspout potential at the very least. Who knows? Possibly a brief tornado or two along that. That's north of Highway 15. Looks like Vince is all over it. Hit my phone. Ooh, yeah. Definitely a bulge right there. Let's take a look at some of the velocity correlation coefficient. I'm not seeing anything that is screaming tornado, but that's also on the edge of the dry air. But there is a bit of a circulation, wind away, just a convergent node right on the leading edge of that bulging hook that's starting to poke out. You can see a pretty classic hook that's reaching out. It has the cyclonic curvature. This is what has prompted that warning. Still, I think this is converting into a windbag, but remarkably, the southern edge of that line has been able to dominate and reach back out toward the outflow boundary. You can also see the very high echo tops on it over the northwestern portion of the tornado warning. Echo tops going up to like 60,000 feet. So that hook is definitely trying to bulge out. Highway 15, looks like Vince is heading north of Highway 15 now. There's the hook echo poking out. There's the tornado warning. Still radar indicated tornado warning. Poking east, west to east. Look at that thing poke out. There you can see the boundary. And it is actually riding the boundary. So interestingly, the outflow that was caused by this conglomerate of a storm in the first place has propagated out and then caused this storm to try to reach out to the unstable air. It's a last gasp, but it's trying to reach out to that unstable air. Look at that, like a finger just sticking out. Big time finger reaching out. I gotta post this. Big hook-like appendage reaching out like a finger. Tolna, North Dakota, take shelter. Get in your safe place. That hook-like finger that's reaching out toward you is definitely an issue. Wow. Tornado warning in effect. Tolna, North Dakota, get in your safe place. Get in your safe place. A tornado warning has been issued. Wow, look at that hook-like appendage that's reaching out right now. Tolna, Pekin, McVille, all those locations along the Highway 15 corridor. Doesn't look like it's a guaranteed tornado yet, of course. It just shows some convergence right on the tip of that hook echo. But that's the circulation. You can see this RFD starting to bulge out right along the Highway 15 corridor. This would be the area of rotation just to the west of Tolna, north of this bulging RFD. There's also some decent rotation further north as well, to the west of Stump Lake. Keep an eye on that. Additionally, up near Stump Lake appears to also have a hook-like appendage reaching out, even though Stump Lake is a little bit behind the boundary. Also seeing some rotation to the west of the Stump Lake. This one's reaching out. You got a lot of shear along the northern edge of that reaching out hook. Big shear zone there, potential vorticity getting stretched into the vertical. Right on the leading edge of that nose is where the MAC convergence is going to be. It's like a finger reaching out. This is the outflow boundary. So this outflow boundary here was caused by rain-cooled air, by this conglomerate of storms that were developing along the boundary. This thing got pushed out, and this storm had no choice but to try to reach out its updraft into the unstable air. So that's exactly what's happening with this hook-like appendage. It's possible this storm could ride all to the southeast, eventually toward the Mayville area. Could easily happen. But relatively broad rotation. Let me see if we're getting any debris that's getting lofted in the air on the correlation coefficient. Not seeing much in the way of debris. This up here is obviously just due to the gradient in the reflectivity. It definitely is not a tornado on the ground right now. Could be a brief one. Just to the west of Tolna has some potential, but this bulging RFD, you got to wrap back behind the line to see that tornado potential. This is the bulging RFD right here. Big westerly surging. And that creates shear vorticity on the northern periphery of the RFD. You get a lot of cyclonic curvature up there. You get the development of tornado-like vortices. And that's how you get the development of tornadoes. In between Tolna and Hamar. Another circulation up near Stump Lake. That's at least a bulging out little RFD ripple, probably right over the lake. Might even be able to get a water spout or two up near Stump Lake. But just watch that appendage reach out. And look at the look at the outflow boundary surging south. It'll be a race. We'll have to see if propagation can dominate enough just to keep this supercell translating southeast. It looks like it's going to get choked off up there, but you never know. Sometimes these things are really resilient, and with that approaching trough, there's a chance that this storm is going to propagate a little bit faster. We've also got a windbag that's organizing south of Fessenden, west of the Carrington, North Dakota area. Big windbag punching out west to east. Definitely some big straight line wind potential possible with that storm west of Cathay. That's south of the severe thunderstorm warning. But I think what we're going to have happen is these storms are going to consolidate. The trough's going to arrive from the southwest, and you're going to start to see some greater storm motions with this. But this hook is barely reaching into the unstable air. If there's a chance of a land spout, it'd be right where this boundary meets up with the hook-like appendage. That's also where we could see the strongest velocities in a storm relative sense, just west of Tolna, northwest of the RFD. This is a bulging RFD right here, surging out RFD. And the north side of that RFD is where you get the generation of cyclonic vorticity. It is trying to reach out. Let's see how the ecotop... I imagine the ecotops are quite high right at the tip of that hook. And that's exactly what's happening. It's reaching into the unstable air with that hook-like appendage and pulling that warm and moist air off to the northwest and contributing to these high ecotops that are happening. There's Batman and Robin out there, right along Highway 15. Who's Batman? Who's Robin? Maybe they're both Robin. I don't know. You got some northeasterly surface winds coming in, halfway between Hamar and Tolna. That's where your rotation would be located. This is your RFD that's bulging out. Big westerly winds happening here, potentially gusting 70, 80 miles an hour. It looks like we just lost the circulation on the north side. Probably just let go of the outflow boundary. There's the outflow boundary. The RFD is still just south of that outflow boundary. This is kind of a mesoscale accident situation here. So this is the real notch of the storm. It's got a couple different notches. I would say 3 different locations where we can get a tornado, or a brief tornado or mesoscale accident. Up here in the notch, maybe moving over the relatively frictionless Stump Lake area, or where this outflow boundary intersects the hook-like appendage. You can get some stretching of existing surface vorticity into the vertical and get a tornado. Or the tip of the hook. You can get a little RFD that'll bulge out of the tip of the hook in the unstable air. The most likely area that I think will tighten up is where the outflow boundary is intercepting the south side of the hook. Does that make it a non-supercell tornado? Maybe. It's associated with a supercell, but it is a little bit removed from the mesocyclone. If the tornado happens in this notch, then I think that would be directly associated with the mesocyclone and definitely more of a type 1 type of a tornado. And it looks like the forecast models were correct in peeling off this supercell from the line. That's why we have this larger scale severe thunderstorm warning now that's in effect for this one. Tornado possible tag, even for the larger severe thunderstorm warning. But this thing is trying to propagate. So is this one that finally went severe west of Carrington. Big wind bag that's developing out there as well. Winds could be increasing. You can see that these storms are starting to translate. They're starting to get a little bit of an elevated appearance. This is definitely an elevated storm. Pure straight line winds. It does look like the outflow boundary, though, comes relatively close to this storm. That's the main outflow boundary. This is the tornado warning storm. It would definitely be a mesoscale accident out here. That's where the outflow boundary intersects the hook-like appendage. Rotation has gone down a bit, but I'm still watching this zone where the outflow boundary meets the tip of the hook. And we're getting a little bit of rotation out there. A little bit of storm relative inflow. RFD bulge just to the south of it. Big westerly winds dominating out here, 70, 80 miles an hour. This is the circulation now, just south of Highway 15. Another little circulation up near Tolna. But this is the circulation that I'm watching. The tip of the hook doesn't look as primed to develop a tornado. It's right where the outflow boundary meets up with the hook-like appendage. And that's where I do think that the greatest... This one's trying to rotate, though, into the parent notch as well, but little notch up there has some potential. That's the parent notch of the storm. This is where the outflow boundary meets up with the hook-like appendage. One thing is for sure, this office just issues tornado warnings like butter, which, you know, I support. Of course, I support that. I mean, I've seen storms that look a lot worse on radar that are producing tornadoes. And you can definitely see, as long as the tip of that hook is interacting with the outflow boundary, that's probably going to be an issue. That's the outflow boundary. It's right near Highway 15. We're looking right at the tip of the hook. Not very much in the way of rotation, but maybe out near the tip of the hook, just south of Highway 15, has the potential of a mesoscale accident, maybe a landspout tornado out there or two. Echo tops are a great way to monitor if this thing's going to be able to stay ahead of the outflow boundary or not. Looks like it's going to. Look at the echo tops that are expanding southward. It's definitely tapping into that warm air, warm, unstable. Moisture is tapping into those low 70s dew points. Hook-like appendage right there. Wow. If you're an amateur meteorologist, you'd see this and be like, holy cow, I think it's got to be producing an F5. But a little deeper analysis, you see this RFD that is bulged out from it a little bit. The orientation is north-south, which tells me this thing's propagating southward, has weak upper level flow. The hook is way long, which tells me that it's reaching out, trying in desperation to access the stable air from the outflow boundary that was produced by its own complex of storms. So it looks like a mesoscale accident to me. Even though it has that ominous shape, it looks like a mesoscale accident, which, as we mentioned, was definitely required to get tornado potential. So overall, the parent notch has some rotation. The tip of the hook has broad rotation. I'm not seeing anything that screams tornado imminent, but I am seeing a pattern that does look conducive for landspout tornadoes. There, you could even use the correlation coefficient to track the outflow boundary and where it meets up with the hook. This is the outflow boundary. This is where it meets up with the hook. And that's where there's the potential for maybe a brief landspout or a tornado. This lower correlation is right due to the gradient of the reflectivity there. In order to get a tornado or a debris signature being indicated by a correlation drop, you really need that blob of the lower correlation that forms. It's a pretty distinct pattern. I've only seen a couple that weren't. But starting to get a little bit of a tightening of the circulation along the outflow boundary. The parent forward flank is separated from the outflow boundary just a bit. Still radar indicated. I don't think we're going to get one from this unless it's a gust NATO along the leading edge of that bulging RFD. I do think that this storm is probably going to continue and it's going to move right along this outflow boundary. I don't think that the winds are going to be strong enough for it to just ramp out into this environment near Mayville. I do think this thing's going to keep going off to the southeast. It might produce a couple weak tornadoes maybe behind the outflow boundary. It does look like it's trying. Right now you're almost getting a separation. You have this cyclonically curved hook almost a new core developing over Tolna. And then you've got the hook-like appendage out here. So it looks like you're getting a new convective burst right where the outflow boundary meets up with a hook. This is the outflow boundary. There's the new convection. There's the other outflow boundary, hook-like appendage, parent notch up near Stump Lake. And so it definitely does look like a mesoscale accident type of a storm, but it looks like a storm that's going to be able to sustain itself a lot longer too. And if anything, the interaction of the outflow boundary with the hook is looking less favorable, and you actually have stronger rotation on the south side of Stump Lake in the parent notch, where you've also got rain-cooled air behind the outflow boundary. Maybe we're getting some funneling right along the reservoir here out of the east into that developing circulation. That's not a debris signature. That's likely just indicating the merger of clear air and high reflectivity. But you might think that this is an RFD bulge near Tolna, but I think that these are just new updrafts that are developing near this, where the outflow boundary meets up with a hook-like appendage. This is the parent notch on the south side of Stump Lake. Watching that for development of maybe a tornado, but scanning higher up, you could see that that is the mesocyclone on the south side of Stump Lake. So Vince and Brandon, you guys got to get northwest. You went suckered south by this RFD. It was a good play because there was a potential for a supercell storm where that outflow boundary meets up with a hook. Now it's time to go northwest because it does appear that the parent circulation, as I'm scanning higher up in the storm, has a mesocyclone on the south side of Stump Lake, north of Tolna. Scanning higher up in the storm, it does appear to be a pretty deep mesocyclone. And there's the lowest level reflection of that mesocyclone. Even though we're using the Mayville radar, it's really not that far away from the radar, so we're scanning relatively close to the ground. So that appears to be the tornado right over the Stump Lake, right over the reservoir, the river into Stump Lake, probably funneling easterlies in that rain-cooled air to the north of the outflow boundary. Look at the windbag to the north. This is the big story. That Michigan City is about to get rocked by this windbag. And the strongest winds are behind this thing. So you can see the bulging boomerang here. Big rear inflow jet. Big westerlies coming into Michigan City. And this is the same convection that caused this outflow boundary to propagate off to the south and then cause that hook-like appendage to try to reach down into the unstable air. But you can obviously see that it's getting pinched. Here is the outflow boundary. This circulation has gotten pinched off on the cold side of the circulation. It's going to get even more pinched by this bulge of a boomerang of a straight line wind event. And then you've got another bulge right here, big RFD bulge. Of course, you want to target the notch of those two bulging boundaries. But in this case, the outflow boundary has pushed out from the notch, choking the notch off from the unstable air, and you just have rain-cooled air behind the outflow boundary. Just pure confusion out there, likely by storm chasers visually trying to break this thing down. It looks like it went south for the RFD bulge, and where the outflow boundary is interacting with the RFD bulge. Now we're going back up north to the parent notch. I'm not sure if any of those plays will yield results, but it definitely does look like a bulge is trying to happen. Maybe it'll even pull this boundary back north, and then the RFD will bulge. You definitely do have a new storm, though, that appears to be developing where the storm is interacting with the warm front. Parent notch still right over there, south side of Stump Lake. Even the one to the west of Carrington, is starting to get a better structure. But I think that as this cold pool continues to solidify, you're going to see it outrun this storm. You'll probably see this cold pool bulge out from the parent storm It'll still exist back behind it, but the wind shear is going to need to increase out ahead of the storm so that the convection can then organize along the outflow boundary, become more vertically oriented along it. Look at this outflow boundary shifting south. So eventually this outflow boundary will probably propagate out ahead of these storms. And then as the wind shear increases, as the upper level trough goes, you're going to start to see convection be more vertically oriented along that southeastward moving outflow boundary. You have this outflow boundary too from overnight convection. That's through the Red River Valley. Dew points mix out into the low, maybe middle 60s through the Red River Valley. But these pipes of moisture are a little bit further west, 72-degree dew points out ahead of these. But look at that hook let go. See it let go, and then you get another bulge to the north RFD bulge right there. So it's trying to wrap around on the cold side. It's easier for these RFDs to bulge from west to east when they're sliding over top a shallow stable layer. It's like a frictionless surface of a big pond or a big lake or something. The RFD will just eject off to the east. So you definitely do have some rain-cooled air that this storm is now injecting. Probably going to convert to less of a tornado threat and more of a windbag potential again. But still, heed that tornado warning. I do want to take a look at a surface map. The key when bouncing around doing these radar breakdowns is to bounce around between the environment, photographs that these storms might be producing, surface maps. You want to see what the environment that these storms are moving into looks like. And there is the surface map. Fargo is 90/66. The moisture is a little bit meager there. You're starting to increase the moisture a bit more, though. The last bit was 63, and as you start to get a little closer to sunset, you'll see these dew points start to come up. You've got a 70 dew point just southeast of Fargo as well that's streaming in. But you've got this pipe of deeper dew points surging up toward that intense portion of the convective line that currently has a tornado warning. A 75 dew point, 75 near the South Dakota, North Dakota border, 71 just south of those storms. A little cooler temperature though, where you get those 75 dew points. But then look at northeastern South Dakota, 94/74 in Aberdeen ahead of that severe storm across north central South Dakota. Oh yeah. So outflow boundary is starting to move out ahead of this storm. Look at it right there. You can see the outflow boundary push off from the hook. There's the hook back behind. The hook is actually bulging on the cold side of the boundary. And I think eventually you're going to see these outflow boundaries just surge out ahead, and you're going to see more of an invigoration of the windbag. That storm west of Carrington is looking pretty good too. The south side tried to grab onto the outflow boundary. Look at it. And then the outflow just went south of it. Right when the outflow was interacting with the south side of that storm, it tried to wrap around a little hook-like appendage. And then now you can see the outflow boundary shifting a little bit further south of it. Still some rotation down there near Sikeston, west of Carrington. But it does look like the outflow boundary has just moved a little bit south of that storm. Observed. One of those gustnados must have been reported. It's way down here, so it's definitely a gustnado or a landspout. Weather spotters. Confirmed tornado located near Pekin. Moving east at 30. I wonder if that was a gustnado because it's well removed from the parent couplet. I'm not seeing anything that would suggest tornado potential. Probably a landspout at the intersection of the outflow boundary with the hook-like appendage on that storm. Yeah, you're not even seeing a hook-like appendage, but you are seeing the potential for 80-mile-an-hour winds now with this windbag as it moves off to the southwest. Straight line winds are definitely going to be enhanced by the RFD structure. I would need to see visual to confirm that because radar just does not really support a very robust tornado. It looks like probably a landspout. Looks like Aaron Jack is on that storm right now in northeastern North Dakota. Good for the Jack family to get out there and storm chase. I am seeing pictures of it now. It does look like a windbag, so I think that that's a large gustnado at the very tip of the RFD structure. Very easy to see, though, that it could be reported as a tornado. Definitely definitely the outflow boundary interaction with the tip of the hook, but to me it does look like a surge in dust right at the tip, right where the outflow boundary is intersecting with the hook. Big dirt. Tune into Aaron Jack's stream. I'm sure that he's got it on his live stream right now. But what a weird feature. I would say that could be a non-supercell tornado. But Aaron was probably the one that reported that tornado. But very weird outflow boundary interaction down near Pekin, Highway 15. That's got to be that bulging RFD that happened earlier. Here's the RFD structure. Maybe an anticyclonic tornado on the south edge of that bulge, where it's also interacting with the outflow boundary. Outflow boundary coming in here. Circulation on the south edge of that bulge. Looks like an anticyclonic non-supercell tornado where the outflow boundary is meeting up south of the hook of the main storm. Wild. And it's also transitioning into a windbag, this storm. The main circulation, the main mesocyclone is up here near Highway 2. Big outflow boundary punching off to the east. And look at the outflow boundary that is now bulged away from that storm. Look on Twitter. Michaela just posted it. Michaela Wasiuk, that's Aaron Jack's fiance. Storm chasing with him today. Check it out on Twitter. MISHEYLA space IWASIUK. I know it's tough, but maybe you just type in Michaela, MISHEYLA. Type it in on Twitter. Aaron Jack was tagged in it. You'll probably see that feature. I'll call it a non-supercell anticyclonic gustnado, but it does look like it's coupled with the updraft. So it was right with this notch, I believe. And it looks like it was on the south side, south of Pekin, where that happened. Looked like one of those hybrid nados. This is the convergence of the boundaries. That's where that tornado would have happened. It's anticyclonic, south side of this bulge, right where that boundary meets up. Just retweeted it, so if you guys want to check out my Twitter too, you can find Michaela's post. She wrote, "This is weird," and I agree. It definitely looked weird. Probably looking south from Pekin, if I had to guess, down to that bulging RFD. Watch it. And it looks like there was a little anticyclonic whirl looking south from Pekin. Big windbag formation happening. Large. Look at the gyre up here. Holy cow. Look at that spin. This right here is a major windbag with 80-mile-an-hour winds ejecting along Highway 2. This is big time. This is the most dangerous portion of the storm. Major windbag, westerly winds, 80 miles an hour gusting out. It's about to hit Niagara next. Big time windbag here. And that actual outflow boundary extends southward from the windbag that has choked off the storm off to the south. 80-mile-an-hour westerlies just bulging out. Look at that ejection of that 80-mile-an-hour straight line wind. Holy cow. Gotta be kidding me. Wow. Damn, I'd love to be on that windbag. Bulging out right there. Big westerly, 70, 80 miles an hour, right along Highway 2. Niagara, you're next. You probably got a mega shelf that's approaching from the west of you. 80 mile an hour, straight line winds expected. You can even see this whole bookend vortex feature here. This gyre, even existing spin out ahead of it. Big westerly bulge. 80 mile an hour straight line winds pumping west to east out of that. Right along Highway 2. Niagara, you're next in line. Very destructive windbag. paralleling Highway 2, the apex of the bow. Big elbow, surge right there, surging out. West to east surge, 70, 80 mile an hour winds behind that. That's Highway 2. Storm trying to develop rotation even out ahead of it, northeast of the elbow. So this windbag here, this dominant windbag that's about to hit Niagara, this thing has shipped out an outflow boundary off to the south that has choked off those storms off to the south. So this is a destructive windbag coming in here. 80 mile an hour, west to east winds, right along Highway 2. Niagara, you're next in line. It's going right now through Petersburg. Petersburg, even though the lead gust front has gone through, don't let your guard down because there are stronger winds back behind that. A big rear inflow jet, 80 mile an hour winds are going to be pumping west to east along Highway 2. It actually went through Michigan City, ironically. That's the state that I grew up in. But Michigan City is down in northern Indiana, northwest Indiana. That ejecting windbag, big time. My focus is on that because I do believe that that tornado warning is going to be allowed to expire. Definitely should. Looks like a gustnado just as the tip of the hook was about to let go of the outflow boundary. Maybe an anticyclonic non-supercell tornado as well. A very interesting feature that definitely had that cyclonic look to it. So from Petersburg, you're about to get the rear inflow jet. Michigan City's getting hammered by it. It's going to be bulging through Niagara next. Big westerlies, 70, 80 mile an hour winds. Big westerlies in there. Westerly windbag. Outflow boundary has gusted out a little bit. So there it is. 80 mile an hour westerly winds coming west to east along Highway 2, Petersburg to Niagara. Batten down the hatches, get away from windows, get in an interior room or closet because these are going to be destructive winds. I bet we're going to type in Petersburg, North Dakota after this and see what looks to be a hurricane, probably much stronger than any tropical cyclone Bonnie could be down the line into next week. 80 mile an hour straight line winds. Even a tour possible tag, but that's probably going to go away. You really want to get on this windbag on Highway 2. Big, westerly, 80 mile an hour winds. Niagara, you're next in line. You can see how fast it's moving, too. It's moving at like 80 miles an hour in itself. So if you were heading west to east along Highway 2 trying to stay ahead of this feature, you probably wouldn't be able to. It would catch you from behind. And then you just get plowed by this windbag back behind. Niagara, Petersburg, 80 mile an hour winds would come in. Petersburg is starting to get some of the strongest winds yet with this thing. Some of those blue colors, you're pushing 40 meters per second, which is 80 miles an hour about. And you definitely have this big, look at the, wow. It even looks like the parent outflow boundary curls into that windbag. Almost creating some inflow in between it, pinching some inflow off into that. It's even trying to spin. You're getting another area of convection developing right ahead of that gusting out outflow boundary. This will congeal with that, and who knows what's going to happen. Probably create some kind of a Frankenstorm. Niagara is about to get hammered. Wow. So I will be right back. Track the leading edge of this straight line wind event as it's moving along Highway 2. I got to take a leak, but I will be back in about 2 minutes. Watch that windbag as it progresses down Highway 2, though, and especially look at this weird return flow. North edge of this bookend vortex, you get a lot of cyclonic vorticity and get a little mesoscale low-level jet, and it's lifted the outflow boundary back north ahead of this feature. Goes to show you just how strongly the north edge of this elbow is generating cyclonic spin. Be right back. see if she was on the stairs. Okay, we got a confirmed tornado, everybody. I'm back. Gotta show you this thing. I believe it's right here. This is not what has been shared so far, but it's got a debris signature on it. Look at that. Destructive tornado that's happening right now. Just south of 34th Street Northeast. East of 113th Avenue, south of Michigan City. What a weird little feature that is. That's an anticyclonic tornado right there. Holy cow, you got to be kidding me. That is an anticyclonic tornado, I believe. It's got to be it. Dang, there it is. I think that is it. It's right at the notch behind the outflow boundary. That is wild. I think that is. Man, there's some weird things happening out here. Seems like anticyclonic tornadoes. So this is a damaging anticyclonic tornado in the southern periphery of this windbag. Stay with me here. This is interesting. I gotta post this. Gizmo's pissed at me. So we are breaking this down. I don't think I've ever seen anything like this. This is an anticyclonic destructive tornado on the south edge of that windbag. This is pretty remarkable. Rare, destructive. Is that Gizmo? Gizmo made it up here. Stay. Did you put her up here? No. Yeah, she went up the stairs. Wow. Rare destructive anticyclonic tornado south of Michigan City, North Dakota. Sorry, I gotta post this. On the southern periphery of major windbag. You got to be kidding me with that. Everybody say hi to Gizmo. She actually ran up the stairs, which was not easy for her to do. But it looks like our anticyclonic tornado on the south edge of this ejecting windbag caused some damage south of Michigan City, southwest of Petersburg. So it's in North Dakota, but there you can see the couplet. Never seen anything like that. I think that's it. Pretty sure that's an anticyclonic tornado there that gets pinched off. Little occlusion, anticyclonic occlusion. I bet that's what they were looking at off to the north. Looking north from Pekin. That was a tornado, anticyclonic tornado. I thought that the tornado was an anticyclonic one looking south of Pekin on the tip of the hook where it met up with the outflow boundary. But it was actually on the south side of the ejecting windbag. North of Pekin. Look at that thing. This is a very rare meteorological event. Hopefully it didn't cause too much damage, but it looks like it went right over Highway 1. And it also looks like Aaron and Michaela caught that very rare meteorological event. It still has lofted debris. Yeah, there it is. And now it's gone. So it does look like the tornado has weakened now. That's the debris signature. A rare anticyclonic tornado observed. Wow. That's incredible. There's the debris signature, and it just dissipated. I wonder if on the southern periphery of this windbag, there's probably another one just south of Niagara there. Look at that. See if we can confirm that with velocity. Looks like there might have been another one in the north central portion of that watch, or that warning, just south of Niagara. But it does look like we are analyzing anticyclonic tornadoes that are developing on the southern edge of that ejecting windbag. You never would think to look at the notch south of that bulging out boundary off to the north, but you just have this bulge happening here, and right along that periphery you're getting the development of anticyclonic tornadoes. Incredible. And look at the outflow boundary is way out ahead of it. And incredibly, it looks like Aaron, J-Jack, and Michaela actually caught that event looking north from Pekin. It was back here, crossed Highway 1, moving really fast. But a very rare event that we just witnessed live on radar. What an honor. Hopefully there's no damage. There could be some structures north of Pekin along Highway 1. The damage indicator, the damage has definitely gone down on that event. And still the most destructive part of this is probably this windbag off to the north that's about to arrive in Larimore along Highway 2. You still have this shear zone as well to the north of the elbow that could try to initiate some cyclonic non-supercell tornadoes. Just love giving Gizmo little kisses. Look at her. There's a huge stairwell to get up here where I go live, and she actually went all the way up the stairs. And usually Gizmo doesn't do that, and she actually went all the way up the stairs. But the anticyclonic tornado that prompted the confirmed tornado warning has since dissipated. We were tracking it here. We saw the anticyclonic couplet as it crossed Highway 1. Watch right here. Boom, right there it crossed. It was pretty tight, too. Boom, right there. Very rare event that we just analyzed on radar. I'm 100% sure that was an anticyclonic couplet too. See it spin off to the northeast as it occluded. That was it. East of Highway 1. The circulation basically went from Highway 1. Didn't make it to Highway 32. Died out in there. But watching Aaron Jajak's video looking north from Pekin, you could definitely see the anticyclonic tornado, and it shows up on radar. Incredible. Storms are trying to develop southwest of Omaha. Omaha twister chasers are considering mobilization out there. We lost our debris signature on this storm. I was looking to the cyclonic generation side for cyclonic tornadoes. See how our north central, those have died across north central South Dakota. Looking in that environment southwest of Omaha, maybe if this outflow boundary, it looks like you got a couple bubblers out there. If these are able to go, they're an environment that's definitely supportive of tornado potential. I do have some high echo tops. They haven't busted through or anything yet. There's about 25 knots at 500 out here. Could be supportive of a tornado or two. Kiss. Remarkable event that we just analyzed on radar. No mesoscale discussions for Omaha area. Those are probably just going to bubble and eventually will suppress. Come here, guys. Here is the latest RAP analysis showing you that environment. Big Cape blob in North Dakota. Strong Cape out there. These storms are largely in an environment with convective inhibition. Post outflow boundary too. But they did produce a damaging anticyclonic tornado right along that gradient. Wind shear is still relatively low. We knew that it would require a mesoscale accident to get a tornado up here. You got sub 50 0 to 1 kilometer storm relative helicity up here. But it's along a boundary. You had a bulging out wind bag. And just on the south side, those 80-mile-an-hour winds, just as those straight line winds were ejecting, the south side of that bulge is where we had an anticyclonic tornado. Still observed, but the tornado is gone, I believe. There's the outflow boundary way out in front of it. There it was. See how it started off pretty broad over Highway 1. And it looked like it was associated with a gradient and reflectivity. And then that outflow boundary surged out ahead of it. To the north of it, you had very strong westerly winds along Highway 2 with a rapidly ejecting wind bag, 80, 90 mile an hour winds, westerlies on Highway 2. So when you had these big westerlies out here that were ejecting, big westerly winds, on the south side of it then you'll get a gyre that'll be anticyclonic. You can almost look at this as like a reverse RFD. So that's what happened. On the south side of those very strong westerlies, you got an anticyclonic circulation down there. You can see how it was correlated with a debris signature. Dissipated halfway between Highway 1 and Highway 32, but there it is. West to east moving debris ball. A lot of people probably initially saw that and are like, oh, that's got to be cyclonic. But you could definitely tell by Aaron's video that it was an unusually looking deal. Interesting feature there is that debris circulation just wrapped up. There it is, and it was gone. Halfway between Highway 1, Highway 32. Windbag continues to push off to the southeast now. Outflow boundary way out in front of this thing. There's the outflow boundary. So it's choked off the main storm from the warm, humid air off to the southeast of it. Gradually, we're just going to continue getting this windbag to organize as it heads off to the southeast. Big convective complex here. We're about to see the formation of a mesoscale convective system as it pushes southeast. But yeah, what an incredible thing that we witnessed here on radar. Anticyclonic tornado that developed as this windbag here is a monster windbag. Very dramatic on radar. 80-mile-an-hour westerly winds right along Highway 2. And on the southern periphery of that windbag, you had the generation of an anticyclonic tornado. It was a relatively broad circulation, but as it got more consolidated, it continued to push off to the east and then dissipated halfway between Highway 1 and Highway 32, south of Michigan City. North of Pekin, across Highway 1. Looked like a lot of dust. Not seeing anything anymore that shows that. If it were to happen again, it would happen right on the south periphery of this bulging area of westerlies. So you have big westerlies that are reaching out toward the Larimore, North Dakota area. And on the southern periphery of that westerly bulge, that's where you get the generation of these anticyclonic gyres along the southern edge. And it's possible that you could get another tornado up here to the northeast of Logan Center, southwest of Larimore, right along that shear zone, even behind the outflow boundary. Very unusual setup. Well, it looks like you might even have a couple little whirls right here, just south of 16th Avenue, south of Shawnee. It's possible that those could be a couple of gustnados down there, little anticyclonic tornadoes that are lofting dust into the air, and that we're actually seeing that. Westerlies, and then you get a little gyre that will form, a couple little eddies. We're relatively close to this. The radar site's just off to the southeast. But it's possible that there could be a couple of anticyclonic whirls here near Highway 16, southwest of Shawnee. They're still kind of there. Little debris drops, Highway 16 to Highway 20, definitely apparent there. Near McVille, that was the early one at 5:17, about 21 minutes ago. It's the one that we were watching. And it was confirmed by radar. Very rare event to have a damaging anticyclonic tornado. Way less than 1% of tornadoes are anticyclonic in the either hemisphere. And to have a damaging anticyclonic tornado is even more rare. So we're definitely growing up scale. Storm scale to mesoscale is happening. We're seeing an increase in the convective inhibition. It's been a while since we've looked at the shear profile in Mayville, so we're going to do that next. Thank you, everybody, for joining me for this weather report. Really enjoy doing these. I do enjoy being out in the field a lot more, but my car is going to be fixed here shortly. I'll pull up the Mayville VAD profile. What in tarnation is that? One kilometer wind is up to 30 knots out of the due south, and your surface wind appears to have gone northerly, northeast at Mayville. So I think that an outflow boundary has just come through the Mayville radar site. You've got a really meager wind shear as well being indicated by this. 0 to 1 kilometer. Well, not that bad actually. marginal, but your 0 to 1 and 0 to 3 kilometer helicities identified right there. About 130, about 170. So those are increasing. So you're getting a more curved topograph, especially with that northeasterly surface wind. But that creates a very curved topograph. You still have a lot of storm relative outflow, 7 to 10 kilometers aloft, supportive of supercell storms. It's not an incredible tornadic topograph. If we had more isolated supercell storms moving into this environment, I'd be a lot more concerned. But right now we've got a wind bag that's producing anticyclonic gustnado tornado hybrids on the south side of a bulging westerly wind. So I'm not seeing any tornadoes anymore. I'm definitely seeing a transition to a windbag. Maybe a little cyclonic vort here southwest of Gilby, well west of I-29. That's north of the elbow that has just blasted through Larimore. Anywhere north of this elbow that's bulging, you can get the generation of cyclonic vorticity. But anywhere to the south of the elbow in the southern periphery, you can get the generation of anticyclonic tornadoes. And that's exactly what happened. Cross Highway 1. It dissipated halfway between Highway 1 and Highway 32, and now we just have this bulging node through Larimore approaching our villa. Maybe along this zone you can get the development of non-supercell tornadoes. Yes. Gizmo. I think that tornado warning is going to be allowed to expire. You do have a tornado or a severe thunderstorm warning in Winnipeg now, as this northward propagating storm has moved right into downtown. So some heavy rain, potentially winds gusting 50 to 60 miles an hour there. Could even get some flash flood potential if these storms proliferate over the Winnipeg area. Not as strong mid and upper level flow up there either. But I would say that the tornado potential has likely subsided. There's a new tornado warning, though, up here for the cyclonic generation side that we were looking at. For the elbow. Just warned the elbow. There's the ejecting elbow that's happening now. Larimore. That was the earlier one that I was breaking down on radar that definitely looked like an anticyclonic type tornado up near Larimore. Big windbags that are ejecting. There's gustnados that are getting reported as tornadoes, but an anticyclonic tornado did cross Highway 1 and then dissipated halfway between Highway 1 and 32. Now we got to watch this area. The northeastern edge of this bulging rear flank downdraft. You can see a lot of westerlies here on the north side of that bulge up near our villa, Amarado. That's where you're going to get the potential development of a cyclonic tornado. And you do kind of have the convergence of these two outflow boundaries. This one's just west of Grand Forks. Here's the Grand Forks area, and just west of that is where this tornado warning is included. I would call these non-supercell tornadoes too. You've got an outflow boundary that's way out, and right at the tip, you can see this appendage that's reaching out right for the intersection of the two boundaries. Maybe you can get the generation of a non-supercell tornado back behind the outflow boundary a little. Snuggle with Gizmo every now and then. But yeah, just to the north of that bulging RFD is where I'm watching. Our villa, Amarado. It says it's confirmed, but it's probably looking north at this gustnado up here. But these anticyclonic tornadoes have also caused damage. They've lofted debris into the air. This is more due to the gradient here between high reflectivity and relatively low reflectivity. A lot of clear air coming into that zone. It's very difficult to see where these storms are located. I think this tornado warning is going to be dropped. Logan Center back to the west. The outflow boundary is now way out ahead of this. Grand Forks now has a severe thunderstorm warning. Includes Highway 29 Grand Forks North. Possible windbag there. 80-mile-an-hour winds being indicated. This is a textbook definition of a windbag. 80-mile-an-hour straight line winds. It's peeling off anticyclonic tornado vortices on the southern periphery of the bulging RFD. You got boundaries all over the place. You have relatively weak upper level winds. At the same time, you've got 80-mile-an-hour low level winds bulging out, creating all kinds of pandemonium. Converging boundaries here near the Arvilla area. Yes. So there's the bulging westerlies, converging boundaries right there just to the southeast of Arvilla, but big westerlies about 60 miles an hour starting to move into that zone. Grand Forks office has been on fire, issuing all kinds of tornado warnings today. And they're difficult setups because they're not really traditional supercell tornado setups, but they're more of these converging boundaries, anticyclonic tornadoes on the south edge of a bulging RFD. Incredibly, we even saw a damaging anticyclonic tornado that passed to the north of Pekin and then dissipated halfway between Highway 1 and Highway 32. That was about 40 minutes ago now when that happened. But I do think that this storm is going to be more of a wind potential, even in Grand Forks along the I-29 corridor near the Red River. This windbag is just going to continue to head off to the southeast, and eventually as the wind shear increases, it's possible that this convection could be more co-located with the gust front. When you get greater wind shear, you get more vertically aligned convection right along the leading edge of an outflow boundary. This area up here is still that big windbag. This is the mesoscale elbow here of the windbag. Big westerly, west-northwesterly winds back behind it. Along the southern gradient of that westerly surge, we've even had the development of anticyclonic tornadoes, some of which have been damaging. The one that crossed Highway 1 to the north of Pekin, dissipating halfway between Highway 1 and Highway 32. Keep it here live. If you know anybody in the Grand Forks area, share this stream. Let them know where they can find this real-time weather information. I know I'm not storm chasing out there, but my next favorite thing to do is to break down this radar. Turn green mode. Definitely got a mesoscale bulge here, and it's the convection's trying to reach out along this boundary. It's trying desperately to reach out to the unstable air. And now you can see that the outflow boundary has now moved through Grand Forks Airport. But this little appendage is trying to reach out to this warm air. And I think it's too far behind the outflow boundary to actually accomplish it and to actually reach out, latch on to that relatively warm air that's located at the intersection between those two outflow boundaries. But it could. You could get the convection propagating out, reaching out to that zone, and you could certainly get another non-supercell tornado potential with that. This tornado warning does not include Grand Forks, but it does include the Grand Forks Airport. Still got the observe tag on it, probably for a confirmed gustnado or anticyclonic whirl. I think that these are definitely non-mesocyclonic tornadoes. but they're still capable of producing damage. We saw a pretty rare event with an anticyclonic tornado that was on the southern edge of that bulging westerly wind there. Still watching this little appendage extending out from the elbow region. Mechanic, you're just on the north side of the tornado warning. Emirado, you're right in the path of that little node, so might even be able to get another anticyclonic tornado, especially if this bulges out and you get big westerlies there. Then I guess you could excite another anticyclonic tornado with a little inflow on the south side. What a weird configuration for these non-supercell tornadoes that we're getting. Gizmo is helping me break down radar right now. They smell so good. Smells so good. Wow. Oh, like a dryer sheet. So there's the elbow. Big winds also possible up there. A little bit less. I think the 80-mile-an-hour winds are right on that bulging elbow, which is west-northwest of Grand Forks. Even if you don't get a tornado, you could still get destructive straight line winds of this configuration. Little mesoscale bulge there. And if this bulges out again, then I think we can excite another anticyclonic tornado. Another rare, damaging anticyclonic tornado. It'd be to the northwest of the Grand Forks radar site. Outflow boundary is still way ahead of the convection, but you do have these converging outflow boundaries south of Highway 2, nosing up to that little appendage that's reaching out toward Emirado. There's the Grand Forks International Airport in the northeastern edge of the tornado warning. Thank you, everybody, for tuning into this live update. We are dominating radar coverage right now. Hook-like appendage reaching out. There's the Grand Forks International Airport in the northeastern edge of the warning. And it does look like this little hook has gotten more robust on the latest radar scan. Definitely more of a non-supercell tornado. You can see these outflow boundaries bulging way out from the convective line. You do have kind of a mesoscale bookend vortex on the north side of that bulge. But definitely not seeing a ton of rotation out near our villa. Just this bulging gust front heading toward Grand Forks. Forward propagating boundary. Not seeing a ton of tornado potential in with this anymore. Watch as the outflow boundary is surging way out ahead of this now. Even though you can tell that these little storms that are developing are rocketing northward with an intensifying low-level jet. It does look like there is a little bit of a sagging south of some boundary that may have forced some northeasterly winds at the radar site that we saw, but let's go back to the radar. Let's go back to the VAD profile again. The VAD or VAD profile at these radar sites is a way to kind of analyze the real-time shear profile. The photograph is definitely getting more elongated. Your 1 kilometer wind, though, is still shy of 30 knots at about 26 knots or so. 2-3 kilometer winds, a little bit more southwesterly. Starting to get a little increase in the mid-level winds as the upper jet is arriving. Those are starting to get up near 45 knots, 6 kilometer wind at 40. These are going to gradually increase too as we go through the afternoon and into the evening. Might help to eject that windbag across northern Minnesota. Yeah, right at the radar site, though, we still have those south-southeasterly winds. Almost calm, though, at the radar site. Looks like 84 over 67 in eastern North Dakota. .84 over 67 with thunder at the radar site near Mayville. Fargo still 90 over 66, just cooking down there. Northerly cold winds, relatively cool winds to the north. Heavy rain in downtown Winnipeg with those storms. So this tornado warning continues. Look at this outflow boundary that is now sagged to the international airport, and then you've got this bulging, stronger outflow boundary. Gust NATO potential back behind it. I'm not seeing that same potential for damaging anticyclonic tornadoes anymore. You still do have this shear zone to the north, but it's just north of the instability. A little bit too stable to tighten up any whirls within that shear zone. Gizmo's getting anxious. Definitely a windbag's going to continue propagating off to the southeast. Interestingly, this seems to have retained a tornado warning as well. It's for this main storm, even though it's way behind the outflow boundary. Let's see what we got for rotation. Hardly anything. Hardly any rotation here. So these are definitely getting warned, and I'm not really seeing any couplets on there right now. Not really sure what to say except heed the warning. If the tornado warning gets issued for your location, heed that warning. But I'm really not seeing incredible signatures for tornadic activity. I'm just seeing a windbag with 60, 70, maybe 80 mile an hour winds, especially with these bulges that will happen. That one along Highway 2, Petersburg to Niagara, that excited an anticyclonic tornado that crossed Highway 1 north of Pekin. I knew it was an anticyclonic looking tornado, kind of a windbag type of an appearance. Yeah, there was damage. I definitely saw damage on radar. It could have been lofting dust, though. But yeah, that anticyclonic tornado crossed Highway 1 north of Pekin and then dissipated halfway between Highway 1 and Highway 32. And now this convective line is approaching Grand Forks. Looks like more of a straight line wind potential with this thing. I don't really see any more of these anticyclonic tornadoes wrapping up because we don't have those 80 mile an hour westerlies that we had earlier along Highway 2 from Petersburg to Niagara. Just incredible big westerly surge of wind out there. Higher reflectivity is off to the south, but this is definitely transitioning to a straight line wind event despite these tornado warnings that are still. It's obviously transitioning to a windbag. Never really was a supercell tornado type of a day, in my opinion. It was always kind of a mesoscale accident, anticyclonic tornado type of an event, maybe a cyclonic tornado or two if you can stretch existing vorticity along the stationary front into the vertical. And look at these two merging boundaries have now propagated way out ahead of the convection. That's usually a sign that even your windbag is starting to weaken, and that is definitely something that we've confirmed. But still in Grand Forks, especially out near the airport, get in your safe place. Respect those warnings. This one's moving into the stable air as it crosses the Red River. Okay, Gizmo, 1 second. I just can't believe that Gizmo even climbed the stairs. That's the first time she's ever done that. It looks like you can see this area bulging out. That's probably associated with the trough that is now moving into southwestern North Dakota, increasing mid and upper level winds. But this is definitely a severe thunderstorm warning, even a wave-like pattern on the cyclonic vorticity side of the elbow. We're obsessed with these elbows here. Usually right at the elbow, you get the strongest winds, and then you can get QLCS potential and even little QLCS tornadoes, little whirls on the cyclonic side of the bulge. So here's the elbow, big southwesterly winds there, and then you can get little gyres, cyclonic vorts that will develop to the north of that elbow. Look at the S-shaped waviness that's happening here, hinting at some of those gyres, tornado-like whirls, and you can definitely see them out here west of Goodrich. See northwest of the elbow how you get more of that cyclonic spin, more of that shear north of the elbow. Still, the tornado warning continues closer to Grand Forks. I mean, might as well cancel that, because it's definitely a straight line wind event coming in. Outflow boundary is separating from the main updraft. And to me, that wind bag is starting to weaken, but you can definitely see that severe weather event to the northeast. And I think this wind bag is going to reinvigorate as the wind shear increases across eastern and southeastern North Dakota. That's going to continue this across northern Minnesota. All right, everybody. I think we've had a pretty detailed live, and I do think that as this is starting to transition toward a wind bag, I'm going to keep this running and see what that tornado warning does, but just look at those outflow boundaries surging out ahead of it. This thing tried to develop a little gyre, even back behind the outflow boundary, and seems to be dealing with more stable air. Look at that little mid-level, probably low-level, mid-level convection elevated, but experiencing the strengthening low-level jet and then hitting the outflow boundary and just poof, it's gone. Just love seeing stuff like that. So this is going to continue to intensify. Look at even the development southwest of Carrington now, back behind the outflow boundary. You have more convection that's starting to develop down in that location, streaming up into this forward propagating wind bag. It's about to arrive at the Grand Forks Airport, and then eventually we'll also move through Grand Forks. But there's the elbow region that's approaching the Red River Valley. But a lot of dry air is also in place to the east of the Red River. Dew points drop into the middle 60s, 50s further east across north central Minnesota. So thank you everybody for tuning into this radar breakdown. The National Weather Service is certainly going to allow that tornado warning to expire. They might warn additional circulations as they come into the Grand Forks, so definitely get in your safe place. Let this wind bag move through. If I see any development of really damaging tornado potential with this, or even any tornado potential at all, I'll go back live again, especially if it's one of those damaging anticyclonic tornadoes. But please hit that subscribe button if these deep dives are for you. Hit that notification bell as well, and I'm going to be back out storm chasing very soon. We're gearing up big time for hurricane season too. Working on some all-purpose vehicles that can float as well, dominate storm surges. We're going to be bringing out the storm surge sensors again. I got to reach out to Mark again about that, as he is working on our hail project now. So he's identifying hail sizes with machine learning, tracking falling hail as well, identifying the fall speed of hail. Just incredible work that Mark is doing right now. Chase and Spin is his name on Twitter. So thank you everybody for joining us here.